I like to be very informal. So we can do whatever questions you want. I have stuff prepared, but we can go any way you'd like. I just thought this is a topic that we don't typically teach or talk about very much, except for in computer science classes. The one we do, we teach it very, very, very differently for good reasons. So I did a quick look, and I can actually show you. So I pulled all CRAN down, and then I just went through because it's so easy to actually process the R language. You can actually parse the R language, and the language objects come back in R, and then you can walk and traverse them. So I might actually check. But 9% of packages on CRAN use S4. A bunch of them use S3. There's that, I forget what it is. I don't have a number in there. There's about 11,000 S3 methods floating around. So it could be used more. The reference classes only count for about 1%, which is probably a good thing. But not enough people actually use object-oriented program in their own code. But if you use R, what's going on here? If you use R, they're everywhere. Classes are absolutely everywhere. Everything in R is an object. Everything has a class. Whether we use it or not, it's there. And that means that if you want to actually think about it, if you want to understand how R works, if you want to reason about your code, you pretty much want to understand the class mechanism. A lot of people use R because of the modeling software back in the early 90s. A white book came out in R and S. The defining books are based on their color, okay? And the white book came out, which actually introduced this object-oriented programming approach. And then the people who wrote the book also wrote all the modeling software, and they did it while they were at Bell Labs, or while people were visiting Bell Labs, where they were in the same corridor, and they had tight control over everything. It's an amazingly simple, brittle class mechanism that is still working 20 years later, only 20 years later, and it serves a very powerful purpose. That's the S3 mechanism. The S4 mechanism is more formal and powerful, useful. Everything is based on generic functions and methods. Okay, that's the key idea. Okay, and again, these are just some quick points. One of the key ideas about this is, so what we want in software is we wanted to do something interesting. We wanted to do it properly. And then after that, the good things are we want it to be extensible and customizable. We want it to adapt to different things. Ideally, we don't want to write any more code, and we want it to do something slightly different. And that's what the object-oriented approach does. Okay, so it's just a good mechanism for writing software. Okay, and certainly just for understanding. Let's say leap in whenever you want. Okay, we can. I don't know what you guys know about object-oriented programming. What you do know about how many of you know about? How many of you use object-oriented programming? Okay. Well, I suspect, was it in R? So I suspect that it's probably different. Okay, because there are different types of object-oriented programming, and this is kind of important. Okay. Just to set the scene, we'll get to it in a moment. But there's functional object-oriented programming, and most people don't do functional-oriented object programming. Things like Python and things like C++ and Java are entirely different. They are reference-based, they are mutable objects where the methods live in an object, okay, or in the class of an object, or associated with an object, and have access to data that they can perturb, they can actually modify. And that is not what we typically do in R, okay? And this, so for better or for worse.
Is that also object-oriented?
It is object-oriented programming. It's programming. So, we both do programming, and there's functional and non-functional, not dysfunctional, but non-functional programming. Okay, and they're all programming. This is all object-oriented programming. R now, as of a couple of years ago, has both styles of programming, mutable or reference-based, where you can modify slots in an object, and the object carries around both its methods and its data. Okay, and the methods can update the data. The methods can update the data, and those changes persist across function calls, method calls, and that's what most people are familiar with C++ and Java and Python. And it makes certain things extremely easy, and it makes other things incredibly hard. Okay, so they're both object-oriented programming. Yeah. Okay. This guy up here is functional, and it's not so much the object-oriented programming is functional. It is, but so functional programming was rarely used for a long. Okay, and it was C dominated in C++ and all these other languages emerged, and now all of a sudden, after numerous languages, including R, have actually illustrated functional programming is really, really useful. It's emerging. So there's a language called Haskell, which used to be a beautifully academic language, okay, but now actually is in use. Okay, and there's other languages that are functional. The definition of functional is, you know, if you go look at the CS definition of it, it has a particular thing. What it really means is it means that when you make a function call, it has no side effects. Okay? Okay, now that's almost impossible. Okay? But yeah, that's the ideal. R is a compromise, and it's about 98% functional. Okay, it does have side effects and bad things about that. But basically, what another way to think about it is when you give a function inputs, it will always give you back the same output. Okay, because there are no side effects influencing it. There's no global variables that have been changed. Okay, there's no state, so it's really so mathematically it's a function. Okay, but the key idea is that there's no side effects. Okay, and as I say, R has side effects. When a function plots, it's changing the graphics display. Okay, and that's a side effect, and that's bad news. But aside from a couple of important things, the spirit in which R is written is that it's functional, and that a function, you pass in inputs, they have no side effects, and they give back a result, and you take the result and you walk on with it. Okay, and so if you want to think about this, another aspect of this, which is technically different but related, is that in R, when you pass an object into a function, if it changes that function, the caller never sees those changes. It hasn't changed the original object. It's just changed the value that was passed into the function. Okay, make sense? No. Yeah. Okay. So in C++, Java, Python, anything, just pick your language. You have an object here. Okay. It's some complicated object, or whatever it is. Okay. Let's say it's an object-oriented thing. It's got methods and so forth, but it doesn't really matter. We have a function down here, and it takes x. Okay, and we call this foo. Okay, and it does, and one of the things it does is it says x square bracket 1 is equal to 2. Well, in R, we call foo of object. Okay, so we computed an object somehow that we call foo of object. Now we're in here, and we run this line of code. Okay, I'm sitting up here and I'm looking at what's going on. If I had the opportunity to look at object while foo is running, I would not see this change, that the second value, the first value is now 2. Because what it's doing is done entirely within its own little world. It's made a copy of object, and there's no side effect. It's passed by value, not by reference. If this was in Python, and we pass this object in, okay, again, it's a little bit tricky, but if this guy goes off and changes this guy, I would see it up here. And when this function returns, I will see that change. So it may return a value 3, but it will also have modified x. And that's really useful and incredibly bad. Okay, it's really useful for certain things. And it's basically, there's an awful lot of software engineering research that shows it makes for incredibly complicated bugs. There's now foo calls bar calls something calls something calls something, and somebody changes the object and you don't know who it was, and you keep going, and all of a sudden you see, oh my God, it's changed, it's different, something's happened to it. Okay, and now we have to go find out who actually did that. Whereas in R, it's functional, and it's much easier to reason about the language. But it is harder to actually affect things like I need to return two values. I need to return the changed value of X, and I need to return another value. Then each caller has to say, actually, I'll take those two things, and I'll pull them apart and put them back in the right spots. So it can be very useful to be non-functional, but it's nice to actually be able to do both and choose which one you actually want to use. Okay, so pass by value, pass by reference gets you into the pass by reference is immediately non-functional, but it's not. But there's other aspects that are non-functional too. Okay, it's not just the reference based. But in R, basically, we have S3 and S4. It's very old, very simple, and something you can actually deploy really easily. And it's what all the modeling software is built on. So you can add to it, you can understand it. S4 is a little bit more for structured reasoning about software. It's kind of good for scaffolding software where you want to think about it yourself, and you want other people to be able to reason about it as opposed to just a loose set of conventions. The mutability, where you can actually have this idea as in C and C++, Java, and Python and other languages, where you have an object that has its own methods and has its own data. These are reference classes, and then there's other ones called R6 and so forth. Okay, as I say, I'm not wild about these because one of the beautiful things about R is it's a functional programming language, and once you start making it non-functional, you lose a lot. For people like me, I lose a lot because I like to be able to actually programmatically reason about the code, and oh my God, this makes life so much harder because people can start screwing with objects, changing in arbitrary places, and now the whole computational model is harder. But they are very, very useful. And then the other thing we have is this, which is, and you'll see this in other languages too, but S3 is extraordinarily simple. Okay, what does object-oriented programming do? Okay, we'll get back to that in a second. Okay, it's basically this. It enables code to behave differently. The same code to behave differently based on the inputs. Okay, it's not just that it does this for all code. But basically, very simple way to think about this is, in R, many of you are in languages, so say, here's a data frame, plot it. Okay, and what you will get is you will get the draftsman's plot of all pairwise scatter plots. Okay, you take each pair of columns and you get a bunch of scatter plots. But if you pass in a single column of numbers, okay, or a single vector of numbers, you will just get a scatter plot of those numbers against 1, 2, 3, 4, 5, 6, 7, 8. Okay, and if you put in a categorical variable, okay, so labels is not continuous variable data, then it will actually draw you a box plot or bar plot. So it kind of knows what to do. Likewise, summary knows what to do. It gives the summary function, the data frame, it summarizes each variable. If you give summary of a vector, it gives you a five number summary of the mean, the median, and so forth. And if you give it a categorical variable, it gives you a table. Okay, because it just knows how to behave differently. And and that's really, really nice. So the code is actually behaving differently. That plot function, if you write that, if you put that inside a function, and you hand it different things, that code, the same code, will just run differently because it knows to go off and find the right things to do based on the type of inputs it has. So that's kind of nice because that's the holy grail. My God, we don't have to change any code, and it behaves differently in a good way as opposed to it behaves differently. Okay, everyone happy? Everyone get what I'm talking about? Done now. It's pretty much over. That's it. Okay. Yeah. So there's kind of so one of the things that if you actually buy object-oriented programming, it's not. You don't need it. You can. Sometimes it's syntactic sugar. And the syntactic sugar is good because it makes life easier. Instead of calling plot.dataframe and plot.vector and plot.numeric and plot.factor and all these things, the user just has to say plot, and they understand this. And that's just syntactic sugar, but it's really useful because, as I say, second you change the input type, you've actually got the wrong function there. So if you sort of say, I didn't mean that data frame, I meant a numeric vector. Well, you've hard-coded plot.dataframe into your function. So now your code is much you've said too much. Okay, so then you've actually got to undo that. You've got to make too many changes. So it's just much nicer. Syntactically, it's easier on the command line, say plot, rather than to know exactly what to call. But as you start building these commands up into functions, you still want to keep them as generics, where we will figure out what to do at the time. And that's kind of nice. But it also, once you start getting into a little bit of S3, but then into S4 classes especially, when you start thinking about what sort of data, how do I want to represent things? What's the relationship between these data structures? How can I share code amongst things? You can actually, it helps to reason about it, and also really, it helps you think about it. Helps you potentially actually structure your code. Ours is a very odd language, like MATLAB and other things, to some extent Python, but where you can be typing away, and then you cut and paste your code to put it into a function, and all of a sudden you've gone from, I'm not quite certain what I know what I'm doing, to, oh my God, I'm writing software. And there's, it's kind of passive, and you may not be thinking about it. Sometimes it's helpful to actually step back and say, no, let's stop. Let's think about some structure after you've explored for a while. So it does actually encourage high-level programming, a little bit of thinking about it, a little bit of explaining it to other people. Part of the trouble is you actually have to read up people's code, whereas it's much nicer to say, hey, what are the classes do you have? What are the methods do you have? What functions do you have? Okay, I've got a picture of what's going on. Whereas otherwise, you read the code or you read the documentation, which is there. It's nicer to have more stuff. We also get a lot more checks into these things, but this is the other key aspect, is if you can actually try to keep, a lot of when we're writing code, just chatting with Clark about this earlier, you tend to actually write code based on how you're implementing things. I mean, as you implement things, that changes how you write the code, and it descends into a very, very mix, a sort of big ball of wax that you basically can't figure out what the concepts are, what the details are that are really kind of a little bit arcane, a little bit sort of haphazard, that just grew out of the way you implement things. So it's kind of nice if you can keep all the implementation details away from the actual high-level details, so that it's easy to actually plug in new and alternative approaches. Let's say this way, where you just create a new class and code behaves the same way, but you manage to just, without changing the code, you just add some code orthogonally to these things. So it's kind of helpful to actually keep these separate, which is, let's say, the holy grail for software engineers. Okay, and also this is the other thing. If you take a look at some of the R code in the R base code, some of these functions are like 200-300 lines long. This is really bad. Okay, or you will have huge functions that do 12,000 different things. No one has a clue what they're actually doing. They're really hard to test and validate. Whereas you kind of, once you start breaking these things up, using these methods, you tend to write much shorter lines of code, and that makes smaller amounts of code, but also by breaking it up into small pieces, it's easier to reason about each one. Okay, so let's say functional programming, no side effects. Okay, you're not changing state. Okay, these are the bits that are not functional in R. You've got global variables. People are screwing with global variables. I defy you to find more than 20 packages that do that. Okay, it's just not part of the R culture. So the global variables are not too bad. Okay, environments, people do this with those. Okay. Okay, options, people are always setting options. Okay, and that means that the function will behave differently the next time you call it if it uses any of those options. So that's bad news. Random number generators, well, by definition, we can't keep generating the same random number over and over and over again. So that's a state that we change. Connections, which are access to files and sockets and reading and writing data, those are actually mutable objects because the operating system makes them so. Graphics devices, and we also deal a lot with external pointer code, where we actually hold on to C and C++ objects, and they are by definition mutable. We only have one copy of them, so that's a different computational model. So if you screw with those, well, they're changed, so the function will behave differently the next time you pass the same pointer in. But this is a big difference between functional and non-functional, mutable, okay, and method-based and function-based object-oriented programming. And so what we're going to actually do, what we'll do in the S3 and S4 is we're going to have functions. And functions will know how to go and find the right thing to do for their inputs. It's got nothing to do with the data, if you will. That's associated with an object. It's just the class of the object itself, and they don't know how to mutate themselves. We won't talk much about references because A, I ran out of time, and B, because of say there, I know there's one package which I think I'm a co-author on, and they asked me, why did you do this with reference classes? And I said, well, I wanted to learn about reference classes. And I say, but you never ever use them for the purpose they were intended. He goes, yeah, it was fun. And nearly always you don't need them. And I said they can actually make life complicated. Where you really do want them is when you're talking to another language. Where the other language uses reference classes, you better be able to sort of mimic that. So, so the key idea there is that as you make a function call, they can update their own state. You can do that in R through closures. This is just a semi-structured way of doing things. Okay, and they really resemble Java, Python, and C++. Same sort of notion. Okay, but then they mix with the other sides of R, so they kind of make it an interesting, rich world. Okay, so. Anyway, hopefully, I'm not sure how much you're familiar with this or not. Just yell at me anytime you feel like it, okay? Okay? So the key functions are generic functions. As I say, we have generic functions. You can make them up as you want, or you can use the ones we have, or whatever. It's just a fully extensible system. Or, as I pointed out in other things, you can change the definition of pi in Europe if you want. You can do anything you want. But it's not necessarily a good idea, but you can create anything yourself. And you basically just create functions and methods. And in S3 and S4, that's all we're talking about. Okay? And to say that S3 is semi-structured is putting it nicely. Okay, it's sort of less than semi-structured. It's just an incredibly weak system. If you're familiar with Perl, it's not dissimilar to Perl, where Perl has this notion of I bless an object to be this class, and I'm saying nothing else about it. You know, there's no contract, no structure that you must obey. It just says, yeah, you're good. So that means that in S3, what I'm actually doing is I'm putting a label on an object. Everything in R is an object. So I can take the number 1 and say that is a data frame. And no one's going to stop me. And when I say plot 1, it will try to do the scatter plot of all pairwise scatter plots, and go, I'm a bit confused. Okay, maybe it'll work, maybe it won't. Okay, but you're allowed to say it's a data frame. There's nothing about the fact that you would have expected it to be a list with columns, and all the columns are the same length, which can get you into a whole lot of trouble if you start putting the labels on the wrong thing. Whereas in S4, we'll basically say, no, you're not allowed. Okay, so what's the idea? Users call one function that behaves differently based on the types of the inputs arguments. Okay, let's say the good thing is users don't have to remember one word, plot, summary, whatever it is for each action. And you better hope that that word means what everyone thinks it means. You say plot, and all of a sudden you're writing it out to disk for some reason. Okay, emailing it to somebody. That's not necessarily a good idea. So people have to have this. So coming up with names that are informative of generic functions is important, and actually adhering to what they are intended to do is important. Okay, but as I say, it separates the code out. It does allow us to override and extend functionality for one or more types, and allow us to reuse code. Hopefully, I'll show you this in a second. Okay, and the key thing is we can reuse code through inheritance is one thing. So basically, we're not rewriting the code. And it also gives us relationships, okay? So here, this is how I think most of you would do this, I suspect. Let's take a plot function, okay? And this, you can do this, and you could, and I just checked yesterday, the plot function used to do something like this, and then immediately, it used to do it. Okay, now it no longer does, thank God. But what you could do is I could have a plot function that says, if the class of X equals matrix, draw my pairwise scatter plot. Okay? Okay? That's not really good. And then I could put down on the next page where I could do something like this. If it's a matrix, do this. Else, if it's a data frame, do this. Else, if it's a numeric vector, do this. Else, if it's a categorical variable, do this. Else, if it's one of Duncan's own. Oh, I've got a problem now. It's one of my classes that I defined, and this is a function in base R. How do I get the if statement into that? Simple. I
just copy the code and make my own version of plot. And now everyone has their own version of plot, which is really bad news.
Okay? A quick trick about this is very bad code. Because if the class has more, if the class of X returns a vector with more than one thing, then it'll say, what am I comparing it to? So I really mean, is it matrix inside the vector? Is it an element of class? And what we really mean there is, does it inherit from a matrix? Or is it a matrix? And we want to use these. These are much richer statements. This says, does the class have only one value? And is it exactly matrix? Whereas this down here says, is there a definition for the class matrix? Because if not, you've probably got a typo. Okay, and we'll check that and say that doesn't make any sense. There's no class matrix, so forget X. You've got the wrong premise. And then is will also say, hey, are you a matrix, or are you one of the subclasses? Are you a special type of matrix that actually has all the properties of matrix, but your class is not actually matrix, it's like special matrix, which is a good thing. We want these subclasses, okay, our inheritance of class hierarchies, where we basically say, yeah, I am an orthogonal matrix, which makes me a matrix. Which means anything you do to a matrix, you can do to me, but I have special powers as well. Okay, I'm more specific than matrix. So the is actually doing a lot of work here. It's actually it's building on actual definitions of classes in S4. Okay. Any thoughts, questions? Yell. Okay. Just feel free to yell. Okay. And let me just why is it this? Why this thing is bizarre. Okay, so this thing. One second. Okay, so this by itself does allow us to actually say different inputs will do different things, but that's basically because we're just hard coding. Okay, and there's a finite amount of that can only go so far. Okay, so if I want to actually add in my own class D, you got a mess. Okay, this is already beginning hard to read. If I'm going to read this, I better have it be, if inherits X of A, do this in one line of code, then do the next thing in one line of code. If the body of the if statements is now 25 lines of code, I have no chance of reading. When does this stop? When will I actually switch out? It's also possible that if I put C and D in the opposite order, I will actually get the wrong thing that I actually wanted, because C may be more specific than, or less specific than D if I use the is mechanism. So this is not a very good, stable, structured way of doing things. But as I say, it really becomes messy if I want to add one for D and you want to add one for E. Then there's only this is in R. So you basically have to patch R, beg for people to accept your patch, which is likely to happen in about thousands of years. So okay, and likewise, that's okay if I do D and you do E, but if we both do D, there's a conflict, especially if we don't mean the same thing by D. Okay, D is not a D may mean something totally different. Okay, it's like, so it may be my data frame, and somebody else has my data frame, whatever, totally different things. So we don't even agree on the definition of what we're even trying to do, so therefore we can't agree on what it should do, and there's no way for us to stick this in. Now you could patch it in your own version of R. You could actually modify R and insert it and then reinstall, but this is just a crazy system. We need an extensible system mechanism where at runtime we can actually add this. Okay. Okay. So basically, this is what actually happens. Okay. What we do and what you can do is, if you see a function that doesn't behave this way, you can make it behave this way in a second. Okay. We'll talk about that. But basically, instead of writing down this, if inherits X of A, else if inherits this, and so forth, okay? And having to put this all into a big set of if statements. What we're going to do is we're going to just do this, my fun A, B, C. Later on, I'll find my fun.D. It'll happen way later, like weeks later, okay? Okay? And then we also just we'll define a default one. We don't have to, we're polite to actually do this, okay? And we'll just do this. And then basically what we're going to do is we're going to say my function, and this is going to be my generic function like plot or summary or whatever but you can give it any name you want. And basically we're going to say my function is not related to any of this code. The only similarity to it is my function equals a function that takes an argument. These should be the same. We nearly always tag on dot, dot, dot. I should have done that up here. Okay? And then the only thing you put in this generic function is use the method for my function. And bingo, we're done. Okay? All my problems go away from the previous page and the previous page before that. Okay, everyone happy? That's it. It's as simple as that. I can now, once this is defined, and in my search path, when I come along and define, when I call my fun, it'll look at X, and if it happens to be a class A, it will find this, it will invoke this function. If it happens to be a class D, it will go, sorry, I can't find my fun.capital D. Okay, then I'll use the default, my fun.default. And if my fun.default doesn't exist, it'll give you an error and say, oh, sorry, I have no idea what to do here. And that's, you can define a method for it if you so desire, or choose to change that object and call my fun again with a slightly different derived thing. Make sense? Not rocket science at all. Okay? Okay, so, okay, that's basically how it works. I think I've got that repeated somewhere else later on as well. But that's how you reason about it. Can I find this method? There is a function called get S3 method, so you can actually ask, go find the method for this class. Okay, okay, but S3. So how do you start talking to these guys? You just start. You're already doing it. If you call plot, you call summary. You have a data frame. You have a vector. It's just automatically happening. Okay, so you didn't have to do anything. I was changing the order of these. This is how you define them, and this is how we define them. But also illustrates how you can extend them. Okay, that you can just write your own function there. Okay, so basically to query the class of an object, this class of X as we saw earlier. Okay, that gives you that character vector with one or more elements. If you ever find an object that has no elements in the character vector, please let me know. Okay, that would be absolutely, that's almost impossible. Okay, so, but this is different from the type of X. Okay, how? Yeah, but that's not how it's different. So it's so if I do the following, here's the MT cars data frame. It's a data frame. What's the class of MT cars? It's that. And if I say what's the type of MT cars? It's a list. Okay. So this is
core, more foundational. Sees through factors, sees through higher level stuff.
I like that. But you need that. Yeah. without those, I wasn't going to buy your argument. Yeah. No, I think the word it's foundational or fundamental, or it's a building block. A list is a building block. There's only a few data types. There's an infinite number of classes. We can make classes up as we go along. The way I like to think about it is a list is how it's implemented. It's how it's constructed. The class is how we want you to think about it. What is the concept it's trying to represent? Okay. Some of them like data frame are so core to the language that there's, that really is kind of how it's implemented in some regards, but not really. Okay, the data frame is actually made up of multiple. A data frame is different from a matrix, even though they're two-dimensional structures, because a data frame is a list where every element in the list has exactly the same number of elements, which is kind of like columns in a matrix, but the elements, the columns can have different types, whereas in a matrix, they all have to have, every cell has to be the same type. So they're totally different beasts. They're represented and built in a totally different way. But if we wanted to, we could say a data frame is a two-dimensional data structure and a matrix is a two-dimensional data structure. And they could kind of actually inherit from the same core concept, and that would be good. Okay? Whereas, but how are they implemented? That's a whole different ballgame. Don't worry about that. Okay? And let's try to, if we keep everything up in the level of generic functions, then we don't ever have to worry about how they're implemented. We just basically, somebody has to, but the methods have to worry about it. But everyone else can start calling those generic functions.
and then we delegate them the actual details. So if I want to say, go get the second element of the fourth row, that will be done totally differently for a matrix and for a data frame, but it's still the same request. Okay, happy? So type of is a funny beast. Okay, I use it all the time. I encourage everyone to use class and type of. You always should check what the class is. And if you don't understand what it is, okay, then say, okay, so str structure, okay, it shows you what it is, and type of tells you kind of in one word, tells you how it's actually constructed, and therefore what you should probe. Yeah, exactly.
This after function of that, I will mode. What do you think?
Mode, I believe, is technically dead at this point. So mode is a really, 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 really bad word as well in statistics because it actually means the statistical mode, the most frequent occurring thing. So when the people who developed S first chose that word, it was that was a very poor choice. Okay, and the way mode was actually being used was way, 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 way back. And when we were talking to C code from S, and what you would actually basically say that you would actually change the way that the C code would see the objects. So that was the only thing. That's really where it came from. So I would suggest you just don't think about mode. Sorry, you know, it's a funky thing that I don't really think has any purpose anymore. That's the story I'm sticking to. Okay, yeah. So it's I'd say my experience with it is very much related to C through the .c interface rather than the .call interface. It's that old. Okay, so it's really these two are the two guys you care about. Okay, but okay. So one is conceptual. This is like so. You know what we'll see now is I'll just show you. I'll just So this is another example. Okay, so I'm going to fit a linear model of miles per gallon to the weight of the car. Okay, and this is my model. So what's the class of this? It is an object of class LM for linear model. Okay, there is no representation for linear model in this language. Okay, it's built on, we only have sort of so few data types in R, it's laughable. Okay, it's actually a good thing. So what's the type of this? No, I typed wrong. Yeah, okay, but even the function has a type. It's a closure, and if we ask for the class of LM, while we're at it, okay, it's a function. It is a function. You can call it, okay, but how is it built? It's a closure as opposed to a built-in. Okay, so these different things. Okay, that's fine. So basically, what have we got? We've got this LM thing is how we want you to think about it. It's a linear model. It is the result of fitting a linear model. So it represents everything that we need to operate on a linear model. How do we represent it? As a list. What are the names of LM? Okay. Apparently there's, why do I keep typing this? Okay. What are the elements in this thing? It's got these things. Okay. Okay. If I say M1 equals 1 through 10, okay, and then I say class of M1 equals LM, nobody's going to stop me. Okay, it's a pretty stupid thing to do. Okay, so these two ostensibly are the same thing. If I say, what's the residuals of M? These are the residuals of my fit in a linear model. What are the residuals of M1? I'm going to die later on, okay? I have lied through my teeth as to what I said it was an LM, but it's not even remotely close to an LM, okay? But this is how brittle this system is. I can just say, yeah, let's see how far I get with this, okay? Okay, but I'm allowed to do this. I'm allowed proclaim a class on anything I want. I love the fake joke. For all consenting adults here, nobody made you do it. So you had your hand up? Yeah.
So I think you already explained a little bit. So why would anyone do that? Like things like that?
Yeah. Because if I've got a method method over there that will draw my thing the way I want. Like, let's say a plot method. I see a plot method over there. It needs a list with two things, okay? And I don't know how to call it, blah, 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 but I have those two things, okay? And I just go, here, be this for a moment, and then come back and I'll take the class away, okay? So I can just wrap this thing up and then basically fake it out to be something if I think that's not working. But you also notice that I mistyped LM and M quite a lot. Okay? Twice in a row, I said, oh, okay. So it's really easy to put the wrong class name on it. Instead of LM, I could put M. And nobody was checking that M was even defined as a class. It's a label that we will refer to that oh, hang on a second, I'm going to define a method for this later on, but let me just give you the class now. I mean, that's kind of crazy too. So you're kind of saying, trust me, I'll put everything in place. So people do this for strange reasons. What you will find is this. People will do this. And so you will find in some methods that people will say, I've got everything I need if I just take away a class, or if I just put a different class on it temporarily and then call it, it will do the right thing. And then I don't have to write any code. Okay, so I am reusing code, but I'm bending the system. This would be perfectly fine if I did the following, I suspect. Is that right? Yes, if I do the following. What if I can get this far? If I say M1 is equal to a list with residuals equals 1 through 10, okay? And then I'm going to do this. I'm going to put a structure on it. It's an LM, okay? That's now that thing. What's the class of M1? Okay, by the way, why did it just do this?
Because the thing, if you print an LM, what you would normally get out, there's nothing there, there's only something in the residuals.
So if I just print M, that's exactly what I get. I get the call in the formula, and I get the coefficients and these guys. But why did it do this with M1? I mean, not why did it give me null and no coefficients, but why did it even do this in the first place? Because if I hadn't done that, if I'd done print list of residuals equals 1 through 10, it just prints like that.
Wait, there's a print method?
There is a print method for this. All we need is a print.lm method, and it will take over printing. Okay, so we can do that. And if I wanted to, I can say print.lm equals function of x, and then we can just put down cat, or we just print 1. And now when I print M, the original M, I've taken over everything. I have completely butchered the system, okay? Okay, before we go too far. Okay, now it's gone. Okay, this is how easy S3 is, okay? And easy makes it really convenient and super bad, because you can have a typo here, print.lm2, and it wouldn't get invoked. But this is how easy it is, and it is actually very nice. So you can define S3 methods and S3 classes to your heart's content, and they are very, very useful because, as I say, we can go through it. You know, now we have generic functions. Now we have methods for these. We can encapsulate all the code into a very small method, very specific to LM, very specific to GLM or LM, and all these other things. And then we just start using those generic functions, and that code never needs the high-level functions never need to change, because all they're doing is calling the delegating down to the methods. Okay, and if I call residuals of what was it, M1, I actually get the residuals, because the way the residual is implemented is it goes in and pulls the element called residuals out. If it starts trying to actually do predictions now, it needs the coefficients, and I don't have those, will fall over. But I can sort of fake my way out with half an object if I think that's useful. Because if I actually if I did this now on this stupid thing with the residuals, I could actually call plot, and plot of LM would give me 4 plots, and some of them will be about variations of residuals. And if I don't want to repeat that code or figure out how to go and call the actual lower level code, I can just fake my way out and say, I've got enough for you to use to do, and hopefully to do the right thing. Does that make sense? Yeah. Ask if not, because I'm not here to talk to myself. So that's how. So anyway, so say you can put classes on absolutely anything you want, including silly things like that. Okay. What you can do is this: you can put multiple classes on this. Has anyone ever seen multiple classes on an object in R? Where? Time and dates. Okay, and XML2, we have lots of things. If you take a look at this, okay. So if you actually do sys.time, let's just take sys.time. We just call it now. Okay, and now is that. So again, what's the class of now? What's the type of now? Which means it's a numeric vector, which means it's a numeric vector, but a numeric vector of length 1 in this particular case. This is because it's POSIX CT, not LT. Whoever said this was thinking LT. Okay, and LT will now represent it in a totally different way. Okay, if I do as.POSIX LT of now, I don't seem to have gotten anything different. Why? When I just did that, and then when I did this, So now it's here, and I print it and it's there, and if I do this, nothing seems to have changed. First of all, it's the same time. I didn't recalculate the time, so it's not like the time should be. It's a bad example for that. Now it's still there.
Is it just a list of
the print method again? It's the print method. It's a totally different print method. It's giving me exactly the same visible output from a totally different representation. Okay, so if I take a look at this guy, we call this now2. What is the type of now2? It's a list. Okay, it is a list. The print method for this object and the print method for this object give me the same result visibly, but they have phenomenally different structure. Okay, so what are the names of now2? This is weird. I love this class. This is just so bizarre. There aren't any named elements in there. So what's the length of now2? This is weird. This is totally weird. This one is just, I'm showing you this to say there's a lot of methods going on here, which makes it things really nice. It's the difference between type of and class and so forth. But look, you can do anything. What's the length of it? 1. What's the length of now? 1. If I unclass now, I'm just going to throw away the class of now, the original guy. I get this. This is a calendar, or this is a clock time, should I say. Okay, it's a number. It's a double. The numeric value, single value is the number of seconds since 1970 January 1st. That's how we can actually measure time. Okay, just down to milliseconds. Okay, that's fine. There's only one element, yeah. How's the time zone isn't here? Because we never put it in. If you don't have the time zone, it just assumes it's your local time zone. If you put the time zone in, it will start doing computation. That's why when we actually printed now, it has specific daylight time. But if we told it when we created the time, by the way, it's a different time. Like if we included the time zone information, it would have hung that information off the object. It would still have been this value, but it would have actually then had a time zone as well, which would have affected the printing later on. Okay, and the calculations too, which is really, really important, because when I subtract off 24 hours, we need to know where that is. If we're computing leap years, we need to know what's going on. So it includes them around. Okay, go back to the now2. It's only got one element, and it really doesn't have it. Okay, so what if I unclass now2? If I can just type, hey, it lied. It said it had no names, and it most certainly has names. And it said it only had one element, and it most certainly has more than one element.
And we can lie, okay? Because there's a method for names that says, I don't have any. Okay, and there's a length method for this type of guy. And what is class of now two? It's that guy. And what is class of now? It's POSIX CT. So these two are slightly different. There's two classes for each of these. And what does this mean? Okay, and hopefully if this isn't clear, just please ask me questions. It's not complicated, but it's slightly odd to explain something. Basically, it's this. Remember what I said? When you look for a method, what we actually do, and I can't remember if I've actually shown this. I think I put it up earlier. Be even better. It's this. When we find a function whose body is use method of this, that's a generic function, okay? That says don't do anything except for go find the other function that you should call that's specific to the class of object that we're computing on. What it basically does is it computes the class vector. So this use method basically says quick, grab X, get its class. And it has two elements in the class, POSIX LT and POSIX T. Okay? And then it essentially says put the function name, my generic font, or print, or show, or plot, dot each of these class names. So it creates a vector of this name, dot class, and then default tag down at the end. And then all it does is it walks its way through. It says, can I find print.POSIX LT? Yes, I'm done. No need to check anymore. No, I can't find print.POSIX LT. Let me try to find print.POSIX T. Okay, yes, I found that. Excellent. Now we can go on. Okay, so it goes through and searches for a function, but in this order. And that means that if I could actually implement the if it was possible for me to use the two representations differently, I could actually define the method for POSIX T, not for POSIX LT and for POSIX CT. I could cut down the amount of code I have to write. Okay, by actually inheriting code from some of these guys. So in other words, if the same method here will work, sorry, if I can write a method that only relies on being POSIX T rather than it's a list with these 9 elements, or it's a numeric vector with count the number of seconds since then. If I could write that, then I could actually write a method. Okay, like say plot.POSIX T. I may never actually have to write 2 versions of it, just one. This is going to allow me to set to avoid writing code, avoid changing code, fixing code in 2 different places, fixing bugs in 2 different places. I'm just reasoning about different code. This is inheritance. Okay? If possible, if I can write high-level functions that only use other generic functions or don't really exploit the totally different data structure, data representation of these 2, then I can actually define it once. Does that make sense? So, for example, we can, when we have a GLM, generalized linear model, that's almost by definition a generalization of a linear model. So you might think, well, a linear model is more specific, but it almost works the other way around, which is a generalized linear model has extra information. Okay, so then what we may be able to do is we may be able to use the same plot method for a linear model and a generalized linear model, in which case then a generalized linear model should have class GLM followed by LM. And if we have to, we'll write a method for GLM. But if we can avoid it, we won't. And the real trick, which is, let's see if we can actually override the method, but still reuse it, which is kind of nice. Is this clear at all? Because if not, just yell. Okay, but this is why we put multiple classes on the object. Okay, and in that order. Yeah.
Is all this so far, these are S3 classes?
Yeah.
So this is not how it works, or does it also work similarly for S4, or is this just completely different?
I would like to think that I've tried to actually describe this conceptually. Okay, except for I said, how does it find this? That this is an implementation detail. I've told you this because
I think helps to say, okay, that's all I need to do with name this stupid thing. But otherwise, in terms of inheritance, the concept of it, it's the same idea we're going to use in S4, which is basically, I'm going to have a class, and I'm going to have a subclass, and the subclass may need its own methods, but if I can avoid it, I'm going to actually just write a method for the top class, and then many subclasses will inherit that method. And hey, look, I've got savings of code. Okay, and that's going to be the same idea. Now, in the S4 world, it's going to be a big difference in the S4 world. A GLM and an LM and POSIX-T, well, POSIX-T and POSIX-LT and POSIX-CT have absolutely no commonality in their representation. One is a number, and the other one is a list with 9 numbers, okay, or 9 columns. Numbers don't agree. They couldn't be further apart, okay? The numbers, the fact that they even contain numbers, the numbers mean totally different things. Whereas in S4, what we're actually going to do is we're going to say, if you have a base class and somebody extends or inherits from that class, they're going to have the same structure. They're going to share the same same fields, the same data slots. And then the second one will have a few more maybe. Okay, so they will actually share some physical representation in common. But so this is even better. You can literally just say these two totally unrelated things are actually the same, or conceptually. But yeah, we're just going to do this. So this is how you actually build an S3 class, an S3 method, should I say. Suppose you actually have an existing function that you think should be generic. So suppose there's a function in R, in base R, or something like that. You go, God, I wish I could hijack that. And we do, okay? Very minor way. So unless you're really, really running very intensive code on object-oriented stuff, it's not going to be a problem. But basically, this is an existing function. It takes X, Y, column, red, and this is kind of the funky thing. So you see this function. We can go through. We can randomly pick one in R, and we can turn it into a generic if you want to go through the exercise. This is the existing function. We want to write a method for foo.myCleverClass. Okay. So this is not a generic function, so I need to make it a generic function. All we do is we take the definition, we rip off the top of that, and just change the body to the use method foo. Done. Okay? By the way, just as a general rule of thumb, always add dot, dot, dot at the end. Okay? Just a good thing. Because that means other methods can actually take extra arguments, or extra parameters, which can help control them, and all the data, all those arguments will get passed down. But if you don't put that in, it'll just say, "Hey, you're giving me too many arguments." Okay, so this is a very flexible mechanism for. I think it's just gone down off the page. Let me just see. Let me just do this. Okay, so what would we do? Okay, we just add dot, dot, dot. So the definition now should be X with dot, dot, dot at the end. Okay, now, not all methods should. We have a function that needed X, Y, and call. Okay, in the example, this is the way it was originally defined. Whoever wrote this had a very specific purpose in mind. It takes X, and it takes Y, and it takes color. Hang on a second, my thing that has no color. Why do I need a color in here? Okay, so that kind of is an optional thing for a specific method. It's for drawing an object or something like that. Okay? And somehow, again, there's an art here. Foo is a generic function. I'm not going to pick one like plot or summary. Plot, not my take call equals red, and everyone's plotting. But in other cases, we might sort of say, get background, get foreground, and then this might be background equals red. Not everything may have a color for the background. So it may be appropriate for a method, but not for all methods. In which case, we should take it out of the generic function. Okay, and likewise, we also often see the current definition of plot in R. So I want to say plot this object, plot a data frame. The definition says plot takes X and Y, and then it looks and says, is Y missing? If Y is missing, then I'll just look at X. So you're kind of looking at the values. It's got an if statement in there. So that's bad news. Remember what I was sort of saying about these if statements? So that's not good. So to me, you may not need Y either. But what we do want to allow is that a method called foo of my special class could take Y and call,
So we could just take all of these guys out and put dot, dot, dotting. Or we could have X and Y and then drop call out. And then this is what we'll actually do, okay? So we'll basically say, okay, so this is what we would do. We started with a function called foo. Immediately what we do is we take foo and we assign it to foo.default. That'll be our default version. Okay, so we haven't lost that. Okay, or if we know that it's not appropriate for all classes, we'll say it's foo.dataframe. Okay, if we know it's only for data frame. Okay, so we may make it specific. And then we define our generic function. And then we define other methods with on a separate line. Okay, we basically say foo.matrix takes X, and basically now we can say, oh, by the way, I need a color. Okay, so now we'll give a label, our parameter name for the color. If you don't specify it, it's red. If you do specify it, we'll pick it up in here. And if you put down main or CEX, we'll pick it up in dot here. And any of the other methods, if you happen to put column equals red, it'll get picked up in dot. And if it dispatches to another method, it'll be ignored. So it's safe. Okay. This is all you need to do to actually create to convert an object. So you know, I'll be doing. This is the LM function. Look through it and look for use method. Doesn't exist. Let's suppose we want to actually make this into. Let's do something really stupid. Okay. So we could say it expects a formula and data. Okay. But let's just say if you just give me data. Okay. I'm just going to say, I'm going to look for an element in the data frame called Y, which would be my response. This is a really stupid thing. Okay. Okay. And then we can define a method for a data frame. So we would fit a model for a data frame out of a formula. Okay. It's again, pretty goofy thing. But we would just override this, okay, in the usual way. And then what we would do is we would call this LM equals, we would take this LM and we assign it to LM dot what? Default. We always could. Then we just get an error if something bad happens, but that's okay. If you call LM with stupid things in it, you'll get an error anyway, so that's fine. So LM.default makes perfect sense. Or alternatively, what we could actually do is we could actually go through and look at this, okay? If method equals blah, blah, blah. See, the trouble is there's a few if statements and funky things going on here. We could actually clean this up a little bit if we wanted to, by actually saying, you know, let's write one that takes a formula. Okay, because a formula, you know, Y tilde dot is a class. It has a class formula. So we could actually say, okay, we could specialize this code knowing X is a formula, which means we now know that this other guy is a data frame and so forth. Otherwise, we have to go through and actually start figuring out what's going on. So we could clean up this code if we wanted to by actually specializing it for formula, for data frame and so forth. Did you get what I mean? Okay, so we can start writing them. Let's say I'll show you some in a little bit as to where we're doing this. But there seems to be an awful lot of stuff going on here. Okay, that we could possibly clean up. It's a lot of extraneous little details. But that's one of the ways we would actually. That's all we need to actually do to find this. So here is another, okay, here's an example. Okay, there's some technical details that we've just gone through about how you actually, mechanical details, how you define it. You put a class on an object, you make a function generic. If it's already generic, you win. Okay, and you don't have to do anything. Then you say plot.my class name, and you just implement your method, and it gets picked up, and life is fine. You can call it. It's syntactic sugar, just so it hides things, until somebody else, another function calls, and then it's now oh, that function that you're calling that also calls plot is behaving differently because you've given it something different and you've given it a method. Okay, and this is what I wanted to do. So if you were here last week, we were doing OCR. Okay, and so one of the things I wanted to do. Okay, we have this thing. So the Tesseract package, which does optical character recognition. Okay, the way we intended it to be used and the way I almost never use it, which kind of illustrates that it's a bad design choice, and I'm going to fix that now. I'm going to show you how we fix it. Okay, the simplest way to get around this. Okay, you create a Tesseract object for good reason. You just give it a file name, an image, and then you say, okay, just hold on to that, prepare yourself, get ready, and I'll come back in a while and I'll get you to actually do the OCR, and you'll just
hold on to the results, and then I'll come back and I'll ask you a bunch of questions about the answer. Like to give me the actual text, give me the confidence, give me the alternatives, okay, as to what you actually guessed. So this makes sense to hold everything into a sort of central object that we query across multiple calls. And then it makes perfect sense to say, okay, just plot the TS, this thing, which will actually, I can run this code if you'd like, okay? But what it actually does is now it goes off and does the OCR. That's what plot will do. If it's already done the OCR, it doesn't have to do it again, okay? By the way, that's an external C-level object that's got mutable state. That's the beauty of this, because if it's not, if it hasn't done the OCR, calling plot will trigger the OCR and for it to cache the result so that so it will change itself. That's where we want references. Okay, so it makes perfect sense in that case. Okay, so then what do we do here? We get an object of class Tesseract base API. I don't know why it's called that, but you can call it anything you want. Okay, okay, and now there's a plot method for this. Okay. Okay, and that's absolutely fine. And what this actually does, I'll show you. Okay, it actually just what it does is it does all sorts of nice things, pretty high level in the sense of the functionality. So you'll get it calls get boxes, which gives me back a data frame with the XY coordinates. It gives me the text, and then says, by the way, Mr. Tesseract, tell me what image you were drawing. So give me back the name of the file. I didn't have to specify this. This is very handy. I can query the object and start, and I can, by the way, what are the dimensions of that image? So I can lay out a plot, and I can draw the image, and then I can draw the actual resulting text by querying all these things. But these are all methods. These are all high-level things, so I could slide alternative implementations in. By keeping them in terms of generic functions, it means I can slide in a specialized class of Tesseract and get different methods getting triggered if I so desire. But what I actually want to do, for some unknown reason, because I'm lazy and impatient, instead of writing 2 lines of code, I write 1 line of code, which is, hey, go get the boxes on this thing. So first of all, if you think about this, I need 2 versions of get boxes, don't I? One, you can't see it here. Get boxes goes off and actually says, do the OCR and get me back the XY width and height for each box that you recognize. Okay? One version of it takes a file name, the other one takes the Tesseract object, and another one will take an image that I've already read in. I need methods for these, don't I? Or I can do it through methods. Is this clear? Am I talking to myself? I'm not done. So if I had a get boxes that took a character, then I'd read that file name. Okay? If I said get boxes that took a Tesseract base API, I would know just call a different mechanism to retrieve, to do the OCR. And if I had a picture, okay, I would have a method for that. How do I do this? I define get boxes as being a generic function. And then I write methods for .character, .Tesseract base API, and so forth. Okay? But this is my annoying part. Okay? So this is an example where I want to actually have methods. Okay, I wanted to actually be able to say, if I'm coming in from a file name, do one thing. If I want to do it, if I am coming in with the Tesseract object to do another thing. And what I really probably want to do is I want to have, if you come into the file name, call Tesseract and then delegate to another method. Don't I want to do it? Does that make sense? So in other words, I just turn the file name into a Tesseract object, and then keep going as if I had a Tesseract object, which means I can call another method, okay, with the type. So I can write very small line functions to do this. But here's the bit that I actually want to do, okay? This is what I have to do by hand, okay? Because I wrote the Tesseract package and I don't use it the way I meant people to use it, okay? Here I do this, I get the bounding box. I look at the bounding box and I'm very happy because I just want to see the text. I'm impatient. I want to see the text. Oh, it's better than I thought. Oh, now I want to see it on page. Why did I do that? Okay, so now I have to call the plot.ocr function, which is not exported from the Tesseract package. And I got to say, the bounding box is this. Don't calculate it, I've already calculated. Oh, and by the way, here's the file name, so you can put it on the back. So I got to repeat the file name. I got to call this hideously ugly. Okay, and then actually what I really want to do, I want to spell check the words, and any words that are spelled incorrectly by the spell checker, I want to color those red. So I want to see everything aligned laid out on the page. I want to see the red ones as being wrong, and I want to do all that with the minimum amount of code because I don't want to write more code. And the reason I don't want to write more code is I already wrote that code. That's not a big deal. But if I keep changing that code, I'll have to keep changing the one I rewrote to mimic it. Any changes I make in the original method for this, I want to continue to use. So I've got a slight bit of ideally we want to actually reuse a bunch of code. Okay, here's a thing I did. Oh, there's a file, I put this all on Git. This is actually on Git before I started, so it's all sitting there. I went through this exercise just yesterday. It's quite simple. This is a thing. I'm actually going to start from scratch, essentially. Yeah.
So, in case of when you have message programming with Python. So it's like when you say pass, then dot function.
Yeah.
So you have the data on the data frame. You say data frame dot
yeah.
mean, for instance. But in this case, in R, the sign is the other way around. So you have mean dot class mean dot data frame. Then you use generic function.
Yeah.
Okay, so in message testing, when you have that option, you say class dot method, and then you can pass some arguments.
Yeah.
Like access 0 or 1.
Yeah.
What's here?
Yeah, that's what that's.
Sorry, I'm sorry.
No. Is it that? So you're getting at an important. Well, there's an important point behind that. But no, the way we define these, when we defined our, I mean, this is a plot function, okay? And it takes x and y and dot, dot, dot. So you just say plot, plot my data frame, y is 2, color equals red, CX equals 10, and it takes all of those arguments, and I hand them to the methods, and that's no problem at all. That's why we put the dot, dot, dot in our definition for the generic function, because we want to say, we'll take any number of arguments. But what we expect, we're also going to name a couple of arguments that we think are going to be widely used. So no, we can pass on anything. One of the big differences is, some people get very upset about this. I don't. But the idea in Python and Java, where you actually basically say data.frame my method, is that it lives in that thing. It's not a global variable, and that means it actually. Some people argue this. It's got single dispatch. We only look inside the data frame. Now, there's inheritance involved. So if you have a subclass of data frame, you look in that subclass, and then you look for the method above. But you're still limiting it to only look in the data frame world. So it's already filtered. Now that doesn't bother me at all. Okay. In S3, to jump ahead a little bit, okay? In S3, what I haven't said explicitly is we only look at one argument where it's typed, which is almost the same thing. We look at, so we look, and typically, now when we say use method of my function, we can actually say which variable. So if we want to do, we always use the first argument. Yeah, we name the first parameter. Okay, so we have plot x comma y, use method of plot, we always look at x for the type. But we could be perverse and look at z, okay? And so okay, take the class of that. And that's what we do. We take the class of the first argument, or whichever one we specify, and we dispatch on that. But we only dispatch on one class. Okay, more to the point, we dispatch on the vector of classes of only one parameter. It's okay. It's not, again, this is cheap and easy, okay? And it works really well. What S4 does is way better, okay? And that gets us into what some people argue and why Python and Java don't have this, that they're deficient because they don't have this. What we can do with S4 is we can define methods on any collection of the class types, of the parameter types, let's say, okay? So now in the global world, we look everywhere for the closest match of the class types, and we can dispatch all of this as opposed to hierarchically by going into the data frame first and then looking at the methods there. And if I'm pretty certain in data frame dot methods, you can't have two methods in In Java, you can, okay? In Java, you can quite happily have C++. I can't remember if this changed so you could actually have a data frame class, let's say, it doesn't matter what the class is. And you could have a plot method. And the plot method in Java, it could be for for a double, let's say, a double array, okay, and a double array, okay, and we could also have another one which is for a data frame, okay, itself. So you can have two methods that will dispatch based on the classes of their own signatures, okay, but they will be within inside the data frame. This is basically saying, oh look, I still don't need if statement on this. In S3, if I want to say plot a data frame against a matrix, and if I say I want to plot a data frame against a vector, I can dispatch on the data frame, but then I got to do the if statement. So like everything I said about the if statement being bad, well, we can get rid of them for one argument. But for S4, we can get rid of them for all arguments. Okay, so we can basically say I can actually define a method for plot of a data frame, where the second argument is a matrix. I can have another method, a totally separate method, where it's a data frame and an integer vector as the second argument. And a third one, which is a data frame as the first argument, and anything you want as the third, and those methods will be totally separate. Okay, and that's really nice because now we can do what's called multi-dispatch. So basically, on the signature, on the classes of all of the arguments, or any ones that we care about. And what's even weirder, and I'll get to this soon. What's even weirder, because we do this in R quite a lot, especially when you look at things like this. So J. Okay, so this is special syntax in R. This is really a call to this method, to this function, should I say, called x, comma, j. Okay, this is just syntactic sugar for this. This is a function, you can look it up. It's not a generic function, but it will be very soon when we make it so. Okay, so we can define methods for this. So we could have square bracket data.frame for this if we want, or for some weird things that I make up. And we say, okay, this is for a data frame, and this is when j is an integer vector. But what about this one? And I'm skipping ahead because I think it's kind of fun. So we're saying, so I can write a method. If this is a matrix, do one thing. If it's a data frame, do another thing. And I'll show you the code. I pulled it out. Okay, because, okay. But if this is a matrix, that's fine. If this is a matrix and this is a character vector, then I want you to do something different. If this is a matrix and this is an integer vector, I want you to do something different. A logical vector. We have to handle all those cases, and you do not want to write a big if statement. Like there. Okay. The if statement is so long and verbose that you basically can't remember if you've actually been finished all, having taken care of all the cases. Whereas you write separate methods, you can actually check. Okay. So what about this guy? What about, because I need to be able to handle this and 1 and j. So we can actually say, if this is a data frame, this is a character vector, and this is missing, which is weird. Okay, you usually have a class of missing. Okay, you can dispatch on missing. So you have an awful lot of power here to be able to describe what calls you're interested in taking. That's kind of wacky. Okay. Jumping back, nice question. Thank you. It took us in a different direction, but the thing. Here, this is remember what we were trying to do? I was trying to plot the results. I got the boundary. I got a data frame which had x, y with height, okay, and then has the text. And I just said, look, I don't want to go back and get the tesseract that we plot that, and then go and compute the bounding box again or hand it in. I want the syntactic sugar of just being able to say plot BB. Okay, maybe I actually don't want the image in the background, because now I want the text to show up, and I don't want the background to distract me. So here's what we could do. I could say plot.ocr results. Okay, x, y, z, x, and I just write this. I create a plot. I create an empty plot, and then I just actually draw my text. Okay, and that's all I want to do. I just want to see where these things appear. I get all the results back. I have no idea. This is perfectly fine. And now, what do I need to do? I've decided to do it. Here are the calculations. So when I'm in our Python, I'll just type these in. They work beautifully. Okay, now I want to make them a function. So I make a function, I just say function. Now what do I call the function? Let's call it plot, because I'm plotting. Why do I put this on it?
You depend on the function for the CR results, right?
Yeah, so this will be a method. This method would get called if only I had something whose class was OCR results. Well, I know how to do that. I'm just going to put a stupid name on this class. Okay, so I can actually go off and if I think okay. So all I can do what if I just do this? BB is actually a data frame. That's what get boxes returns. I don't want it to be a data frame anymore. So let's just make it an OCR results. Okay, I put it any name I want. Let's call it entity. Okay, it doesn't make any difference what I call it as long as I call the corresponding method. That I'm going to call it OCR results. You should try to actually come up with clever names that actually mean something as opposed to file, okay, or something like that, or that aren't ambiguous. And then I do this. Why do I do that?
So it retains what it had before.
Yeah, because otherwise I am screwed. Okay, because it's a data frame. And if I forget, if I say you're now an OCR results, and by the way, you lost all recollection of the data frame, I won't be able to talk to that thing. I will not be able to use the square bracket operators to get it out because those are actually keying off the fact that they're data frames. Otherwise, it just looks like a list, and it goes like you're not a two-dimensional object, you're a list. So I need to make sure that. So I'm now an OCR results object, but I'm also a data frame, which means I will inherit the data frame methods because I'm not going to change the square bracket operator for OCR results. Okay, so I'm going to inherit all the methods. Nothing's changed, but I am able to override the plot method out. Okay, and that's what. So the inheritance is saving us a bunch of time. We get to inherit a lot of code, but we're able to slide something else in place, and that is really, really helpful. And so this is what we do. We draw this. You can run this code. Actually, all the images there. You can play around with it. All that life is great. Okay, so that's fine, but that's not what I want to do. Remember what else did I want to do? This will just draw the text. There's no image. I didn't want the image, so this is now I can say plot of BB. Okay, I should change my get boxes function to return a class. Instead of returning the data frame, having tested this, I will now go back and change my get boxes to actually return not the data frame, but just put the class on and then return that. And that's great. So you can always add an extra class, something. It's a label that basically tells people, again, conceptually, how to think about it. It's not a data frame, it's an OCR results. And it's a data frame. Okay? So that's a helpful thing. If nothing else, when you come back to it 3 weeks later, you go like, I saved this object, I have no idea what it is. It's a data frame. X, Y, talk with text, I have no idea where that came from. Oh, it's an OCR results thing. It actually has provenance information in it. Okay, so what did I want to do? I wanted to find the words that were spelled incorrectly. Why do I want to do this? Maybe you don't want to do this. I decided I want to actually just, it's done optical character recognition. It's come back and it's given me confidences about how accurate, whether to believe this or not. One thing I'm going to do is I'm just going to basically say, hey, spell check this. If you can't find a word in the dictionary, it's probably wrong. Okay, at least I'll just find them, see if there's any pattern to this. Okay, so this is all good. Okay, okay. Let me just go through this. Okay, so this, as I wrote this, I made some great mistakes, and I thought you should see them because they shouldn't do them. Okay, and they actually illustrate some of this thing. Okay, so that's fine. This was my first attempt. I did it. Then I got more ambitious. Okay, did exactly what I wanted to do. Then I decided I wanted to do more. And the second you want to do more, okay, I'm going to have to take this code and change it. Okay, and the second, if for those of you who aren't software engineers, okay, hopefully you just go, yeah, we just change the code. Okay, no, that means we have to test the whole thing all over and over again, and don't break it. Every line of code has a button, so therefore when you actually change it, 2 lines, 2 buttons, it's just a nightmare. We hate changing code because you break everything, because everything that used to work now breaks. Okay, or you have a good chance that that's going to be the case. So we would like not to change it, but so we can make a copy of it. That's great, nothing's going to break. But now we've got a copy of it, now we've got two things to maintain. That's even worse. Oh, I know that. This is why people don't go into software engineering. Okay? There's better things to think. This is why we do theory. Okay? Okay? So that's fine. So here's a change, and I've actually made changes so I preserved the actual change. So we can actually see the change. This is a bad approach. One of the things I can do with this, just put a color equals black in here. And then I'm going to actually, the problem is here, we don't change the color of the text at all. So there's no way we can influence how that's going to be. But I need the caller plot to change the color. So let's do this. Let's just actually add in a color, okay? Okay, so this is a bad approach to copying that. I should have actually this one I should have actually just added to the original version, because all I'm doing is adding color black, putting that guy in here, and saying nothing's changed by default. So unless somebody changes the color, specifies the color, this is all the same thing. But what I've actually done is, this is a weird one. No, I'm actually added, this is the one I actually added in a whole lot of extra stuff. What I'm going to do, and then there's two things going on here. I spell check. Let me jump down to the bottom. I spell check this data frame. Okay. Oh, while we're at it, let's make a generic function out of it. Okay, I'm going to a spell is a particular type of speller. I'm going to say spell. Okay, and then I'm going to say, hey, spell my OCR results for me, will you? Okay. So what am I going to do? I could actually, and there's lots of ways to do this, and we're going to do them all. Okay, but what I'm actually going to do is, separately from plotting, I want to actually spell check the results, and I want to store the results of the spell checking in the data frame. Okay, or maybe not, but I might. So what we're going to say is, hey, could you spell check these for me? So what are we going to do? We're going to spell check the text column. Okay, and if you're interested, I'm more than happy to tell you exactly the structure of this data frame, but it's got a text column where the text. So we just spell the text. Notice, by the way, we define a generic called a spell, and then I'm calling the non-generic version from the a spell package, which is not generic, but that's fine. It knows what to do. It calls this, and then I pop it into the data frame. I could design this differently, where I just spell check it and give me back the results and use the caller to put them in somewhere or to do what they want with them. I'm defining it this way for fun. And then I change the class of the object again. Now I say it's spell checked. It's not just OCR results. It's got spell checked in. Okay. Okay, class of X, and then I return X. X is now updated. I've modified X. Going back to my mutability, the caller has not seen the changes to X. This is a copy of X. But he or she does see the result that I'm returning back, which is the modified X. And they could assign it to Y. Okay, but it's not, I haven't changed their X, but I've given them back the change object. And they can choose to ignore it, throw it away, or assign it to somewhere else, or assign it back on top of X and kill X, the original X. Okay, so this is, again, I'm using labels on the class of classes to say, this is something more than you just had. It's everything you had and more, okay? So, and you can tell how it's more, okay? So that's fine, I could do that, okay? Okay, then I ran into this problem. Then I plotted this, and I go, okay? I said, they're spelled wrong. Moscow is spelled wrong. I could have sworn Moscow was spelled correctly. And then I thought there's a comma at the end of Moscow, because the optical character recognition doesn't know the comma isn't part of the word. So, okay, so when I'm spell checking, I should remove the text. Okay? So what I do is I put in a punct equals true. Should I remove the punctuation? Okay, and again, this is an example of the arguments that we can pass down. I'm making them up. I'm making them up for the individual method. This method wants a punct equals true. The other ones all have dot, dot, dot. That's okay. Okay? But now I basically say, if punctuation is true, clean it up. Okay, and I put a note here. This is a really bad idea. Okay? Because remember I told you that we change X, but the caller doesn't see X, and we hand it back to them? This one does exactly the same thing. It makes a change to the copy of X that the caller gave us, and then it hands back that modification, into which we put spelled correctly, but we also changed the text. So we threw away the punctuation, which is a bad idea. I just wanted to say, don't use the punctuation when you're spell checking, but please don't screw with my text. Okay, please leave it back. We changed it. So if the caller takes the result of this and overwrites the original data frame, it's lost the punctuation, which is probably not a good idea. I realized that when I plotted them out. Idiot. Okay, fine. So another version of this would be, okay, just make a local copy of text, pull it out, do the change, spell check it, get ourselves back. This, we haven't written the results back into the data frame for text, but we have added it in here. And now life is great. We have a column name spelled correctly, and this is fine. So these are different variations that illustrate an error. You don't write all three methods, but it does, we've introduced a generic function for a spell, okay, which means we've left the old one lying around. We've customized it for OCR results. Okay, so that's fine. That was just to get the spell check, because you should not be doing spell checking when you're plotting. Or should you? We could have an argument that says spell check in our plot.ocr results, and we could do it then. The trouble is, if I've got a huge document, I'm going to be doing that every single time. Whereas I may want to actually pull the spell checking out and do it once and avoid doing it multiple times. So you have two choices in how you design the software, but you can do it. Okay, that's fine. So let's go back up to this. And now what we can do is this. Where are we? So let's say these get incrementally better, I hope. Okay, so this was a mechanism to do it. Okay, we take our original plot.ocr, okay, and we can actually leave this one out now, okay, basically we do our plot again, so I've copied the code, okay, otherwise I'm going to break it because I'm adding too much code here. I could easily break this code, the original version. So now what I basically do is say, if you're a spell checked result, if you're one of these spell checked OCR results where we actually put the answer back in again, okay, well then compute this. An alternative way of doing this, which is even stupider, okay, is I could say, hey, do you have a column name spelled correctly? Yes, well, I'm going to assume that it's a logical value, that it's true or false for each value. I'm assuming I know what it means as opposed to, but if you haven't had something called spelled correctly that has nothing to do with the OCR stuff, I'm just going to assume it is, okay? I'm now using the name of a column, which is a very bad idea, okay? Because this is just a very soft convention that we're actually using. So this uses an if statement. This uses an if statement that checks the names of the columns in the data frame. This is very brittle, yes? Okay, so we can't, if somebody wants to go in and add some extra stuff, this was exactly what we were saying is a bad idea. Using an if statement on the class of this was a bad idea because it's not extensible. So what should we do? And this one's so hideously unextensible that you shouldn't even consider it in the first place. We do. Okay, so this is the short one. Well, what should we do to fix this? Yes. So, well, if there's nothing else, I should pull it out as a method, a separate method for this class. This is for OCR results, but we really have a different object here. It's spell-checked OCR results. So I should write a method for plot.spellcheck.ocr results. And I should then basically copy the original plot.ocr results, change its name, and I can get rid of this because we know we're in the plot, we're spell-checked. I can just compute these colors and pass the colors down here. Yes? No problem. But I hate writing code. I hate copying code because every time there's something about this Heisenberg's principle that when you copy code, there was no bug in it originally. When you copy a bug appears. Okay, and now you've got to fix it in two different places. It's just uncanny that you find the bug after weeks and weeks and weeks of working fine. You copy it. Bingo. There it is. Okay, so we really would like not to. Okay, but we could. Okay, we could just say plot.spellcheck OCR results. Do this, and I'm going to put the colors in here. Why do I put the colors in here? Math labs. So the caller, not me. So that the caller can change them. If they don't specify, we get exactly the same results as we got up here, but they can put different colors in if they want. If they don't like, so many of us
I'm not, but as so many people are colorblind, so red may not be a good choice against with blue and red if we have blue and red. So we may want to choose different things. If you put it in, if they specify it, we'll use it. If they don't specify it, that's their choice. So this is kind of nice. I have a slide at the very bottom. I write code this way. I write a function. I put down x as the argument, function x paren, and then I put down the first line of code and go great. And then I move it up as a parameter with a default value because now everybody can just almost lift everything up. There's only one line of code at the end. Kind of a little bit ridiculous. You can take it to an extreme. But the point is, when I'm debugging, it means I can actually just add the last argument in and everything else flows and I can work on a very small subset of the data rather than going through all the computations. So this is nice, but I've still copied all the code, yes? So here's the magic trick. Okay. Okay, one trick is this, okay? Okay, there's two magic tricks, but I'll get to the one thing. One of the tricks is, let's go all the way back up to here, the very beginning. There's no color here. What if I just added a color argument here and used it down here as a default value? Nothing would change. They'd all show up black. Okay, but having introduced the color, okay, having introduced the color, I could do the following. This is for the spell check version. This is this hideous trick I was telling you about. Take away the class. Okay, I'm a spell checked OCR result. So if I take away my first class, then I become an OCR result. Okay, and then if I call plot again, it'll dispatch to the other method, plot.ocr results. But I'm going to tell it what colors to use from here. And because it takes a color argument, it will now do the right thing. Does that make sense? So this is kind of a hack.
Because it's working with the copy of text here, so it
Doesn't, nobody else knows that we've taken the class away. There's one case where it does, and it's very bad. Okay, but we won't talk about that. Okay, okay. So that's it. So this is a common trick, which is basically you see what we're doing is we're saving writing all. We're inheriting the original method, the plot.ocr results. So this is so common. Let's just do it this way. And this is an advanced version. This one is actually okay. This is as complicated as it will ever get in this case. All we're basically doing is, oh, I'm here. Could you call the previous method the method I inherited, please? Next method says go back. You know the calculation you did when you took my class vector and you typed the generic function dot class and went and looked for all the functions? When you found all those functions and you call the first one, could you call the second one, please? But with the contents of what I've got here right now. So it'll pass X, and it'll pass Y, and I'm overriding CX and call here. So it will magically do all the right thing. And now I have totally inherited this code. Okay? If we've gone through a bunch of code as like attempts to do this, but all I have to do, if you think about it, all I have to do is define the first one, add a color argument to it, which I didn't know I needed, but it was a good thing to do. Okay? Okay, and then I just go ahead and do this. So at the end of this, I only have to write two functions. The original method with the call argument, this guy here, and then this guy says, I don't do anything except for just call the other guy in a slightly different way. Make sense? And we have...
Yes, the method for how I did it. So I'm seeing the next method of plot, and then it's doing that for X, but the next method, you know.
So it's literally doing the same thing as this, except for it's faster, it's smarter. Okay, I wrote this down because this is the way you can think about it. This is a vector which, if you go through, I can run this code if you want, but basically it's and again, you can think, okay, are they weird? All the implementation details. I'm trying to sort of show you how you could think about it. It's much more conceptual than this. We are inheriting the method of the base class, of the previous class, the class we extended. So what we've actually got in this world here, and it does help to draw this out. We actually have a data frame, and we've extended this to be OCR results. Okay, and we've done this down to be spell checked OCR results, okay? And we just kept on accumulating classes. And basically what we're saying is, I'd like to call that guy's plot method, but I'd like to change the way we call it down here. Okay, so basically I just want to go and call that method. And so one of the ways we can do it is we can turn this guy into one of those, which is basically remove this class, and then call plot again. But alternatively, next method has already done all these computations, so it knows where the other methods are, so it's got them cached. Yeah.
Wouldn't it be better to tell it explicitly that you wanted to inherit, you want to use the OCR results one rather than the next one?
No.
In case you then, what if you change the way that you structure this? And suddenly no longer is the next one that one.
That's because you intentionally want
That's because you wanted to do it that way.
because that rope that's hanging around your neck and isn't being pulled, you want to actually bring it in. It can completely and utterly kill you. But the beauty of it is, again, it's an interesting system. It's amazingly flexible. Okay, so flexible that you can kill yourself with this thing. But because what I can now do is, Duncan, you've written this code, okay? Or let's check. I've written this code. You come along and you go, you know what? I'm going to drop something else in here. I'm going to change the class and drop something else in here, and then I will inherit from that. Okay, and so I don't know that you're going to do this. So I'm saying, I will obey this rule. I will just go back to the next guy. So that leaves you the choice to change who the next guy is. Didn't say it's a good idea, but it does mean that this gives you the flexibility to extend to add an extra layer just through the class names. And if you don't do that, that life is good. But you can do that, but otherwise we are actually locking it down as to what the inheritance is, which is a choice. You can definitely do that, but it's a different design decision. Okay, happy? So this is inheritance. Okay, and hopefully what you see. So we don't do this. We just call next method, but it's really not a big deal either way. But this and the second function we had in there with the color equal black argument, we've written almost no extra code to get the colors in there, and we can continue on to do all these different things. Okay, make sense? Yeah.
Sorry, I have to step out for quite some time, so maybe explain this. But when you have the color argument there, and then afterwards you have this bracketed X $sign spelled correctly, plus I don't.
All that's doing is, so what again, this is if you haven't seen this before, this is incredibly simple stuff, but it's new and it's sort of the pieces floating around. And especially one of the real problems with this is when we get to S4 classes. If we had X4 classes, I wouldn't do $X here, I would use X at. Okay, small little syntactic difference. Huge impact, which is I would be able to show you exactly what was in X. Okay, and then it actually had a field, a vector of spelled correctly, which were logical values. Okay, but that's because ours, the S3 mechanism is just like, yeah, you can put any class name on anything. Doesn't mean we know what's in it. Okay, but in our world, this X is an object of class spell checked OCR results, which is a data frame with X, Y, top, X, Y, width and height. Okay, text. And now we add in another column for the data frame called spelled correctly, which is trues and falses. And we are just assuming it's there. And if you have lied to us, and it's not there, we will get an error message. And it will be a cryptic error message because this will come back as null. And then we will end up with NAs. And oh my God, what's happening? Okay. And especially if you misspell spelled correctly. Okay. So that's what this is doing. And all this is just regular R. It says, you're giving me a data frame which has a vector, an element here. This is an idiom we use a lot. I need to turn this trues and falses into reds and blacks, or whatever it is. So all I do is I turn them into an integer, which makes them zeros and ones, and I add one, so that makes them 1 to 2, and that gives me the subsetting of red and black. So red will be false, black will be true. Okay. And the L there, everyone asks me about is to make it an integer. Okay.
So that's just making assigning reds and blacks to the ones and zeros and that.
Yep, I could do a factor of it, but it's more fun to have cryptic code. No, it's really not.
If you use +1L versus as of integers, there is a difference. This one is over the other.
for 1L, like using 1L as opposed to as that integer of 1.
As an integer of x spelled correctly.
And that's, I still need to add 1 to it. No matter, even if I do as that integer of this, that will give me 0 and 1. I need to make it 1 and 2s. So I still have to add the 1. So I don't want to do it on that. And I like to type as little as possible. Okay? Especially when you keep it. Okay? So that's all that's happening there. Okay? Any other thoughts, questions?
And then, so the
Yep.
first part is turning it into red and black, depending on whether it's spelled correctly or incorrectly, but then you're asking for the plot to be just like the
Yeah.
OCR results.
So this is,
highlighted red and black.
as Andrew was saying, basically this is going to call plot.ocr results because in our case, X has class spell checked and then OCR results. So when it goes to the next method, there is one for OCR results. Okay. The other reason for not putting up plot.ocr results is somebody can use OCR results as an actual method for plot. Okay, or whatever it is. We may not find that either.
Did you want to error?
Maybe one there, but we won't get. We may, depending on if they change the name. So this is the weird thing about these classes. Where literally you just put any label you want. It can be a cell. In which case you've got a problem. You know, so you go, why does it keep on coming up with the default method? Oh, it's got a comma at the end, and you didn't see this, and it's really, really annoying. That's where it's nice to. So if you're in a language like Java or C++ or something, if the compiler says there's no such name for a class like this, you're an idiot. Okay, and you get told about this. And this happens at runtime. It goes, fine, okay, we trust you. Okay, and it just appears it doesn't do anything, which is not good. That's where S4 will help a great deal. Any other thoughts, questions? I'll say, you know, if you go through this, you can actually now you can debug, you can understand, you can extend and adapt any of the S3 methods for that R uses, and it uses an enormous number of them. Okay, all you know. So I have a slide somewhere. I can't remember where it is. Somewhere in here, it talking about, you know, you fit a linear model and you just do AB line of a linear model and it just draws a line for you. It's like, hang on, this is weird, because that takes the coefficient and actually adds those, just adapts it to a different code. It's just syntactic sugar, but it can be very, very nice. If you take plot of an LM, it goes through 4 different plots for the diagnostic tests and stuff like that. You can change that. You could change plot.lm, but you're better off not changing plot.lm. You're better off adding a class to your own and then calling that and adding a method for that. Okay. Of course, you could write a function called plot, you know, myplot.lm or my lm plot, and then you just call that instead of plot. Then you have to remember different syntax or different generic functions. So it's kind of nice to override the plot function, the existing ones. Okay, but you can always create new ones that people haven't gotten and make them generic. And making things generic is kind of useful. Okay, everyone happy? When you start writing a package, and writing a package in R takes all of 10 minutes. Okay, it's trivial to write a package. Okay, the parcel things out. Once you've got the code is the hard part to write. The S3 methods are not that complicated. It's the code. The hardest part is the actual code to do the thing you want. Next, this is window dressing, but actually it does help a lot in different things. But when you get to writing a package, you have a namespace and you have a description. And in the namespace, you're going to actually have to say, this is an S3 method. Okay? Okay, you've got a plot, and then there's an S3 method for plot, which handles OCR results, and another S3 method for plot, which handles search spell checked OCR results. And the reason you need to do that is because we can't tell the difference between whether you wanted it to be a method or whether you actually just wanted to call something foo.bar. Okay? A lot of people use dots to separate the names as opposed to underscores or a camel case. We don't know if that's a method for foo for bar or it's just called foo.bar. Okay, so you tell us. Okay, so we don't start finding everything and start mysteriously dispatching functions that never were intended to be methods. Okay, so that's fine. And you also export the generic functions, and then life is good. Okay, S4. Yes. What do they?
What are S3 and S4?
Good question. So S is the language, which is the language that actually gave rise to R.
Okay, so the history of this is that at Bell Labs, they developed a language called S back in the late 60s. Okay, and so it was called S, and then R became R, which so these two guys started developing something that was quite different from S, but then they were coerced to actually make it look more and more like S. Called it R because their names are Ross and Robert, and pretty good to go before your predecessor. Okay, it's kind of fun. But the S, so the S is essentially the defining language, if you will, and the 3 and the 4, well, there was a 2. The 2 corresponds to the Brown book. Okay, we have all these books. Okay, and S1, I don't think you can have. It was like the writing system. And S3 came about in the early 90s, as I say, like it brought in the modeling software and the data frame and this mechanism for dispatching. And then back in 1994 to 1997 or so was S4, which corresponds to the Green Book, which is, hang on a second, this sucks. We should fix this. And that was the last version of S. Okay, and F4, I say, is a very, very different view of the joint program. Okay, it's much more structured, but still functional. Okay, does that?
Yeah, and so when we're writing packages and methods and stuff, we can use either S3 or S4.
You can use either or both simultaneously. I do, and you can use reference classes. You can mix them all together. You can do, and sometimes it's good to mix them all together. They actually have different purposes. You know, as I say. But I'm not a big fan of the reference classes, primarily because a lot of people use them because they're familiar with Python and C and Java, okay, as opposed to because they have good use and a good reason to use them, and so it's just familiarity, and they give up all the functional aspects of R, which is really quite important. But there are times when it's really useful to mix them all together, or any pair of them. And I actually do. I think you'll find if you take a look at the Tesseract package, if you take a look at the read PDF stuff that we were talking about last week and so forth, I mix them both because sometimes it's just more convenient, and sometimes when it's lazy, just I'll use S3 because it's so cheap and easy. S4 because I actually want structure. Okay, because I don't trust myself, and because I want to do this other thing that I was talking about over there, which we'll get to now, which is because I want to actually call a method based not on the class of the first object. I want to call a different method based on the entire signature, the entire collection of inputs and their classes. And if I can do that, then I can really simplify my code down a lot, and sort of instead of having a huge big collection of things, I have a large collection of small things that I can use and check independently and so forth. But you can mix them all together, okay? So S4. So good question. We talk about S4, S3, S4, Green Book, Brown Books. No reason why anyone should actually know about this, so I'm glad people ask. Okay. So we actually have we had a linear model, and it had residuals, coefficients, and so forth, and about 8 or 9 different things. But there was no definition of that, and people can actually just start assigning a label to this to an object, saying, "Trust me, it's enough of what you need to be able for this method to work with."
So I'm just looking at some random packages, but so like this, like for instance with A-bind, it says something about like how S3 generics cannot dispatch off anonymous arguments.
Not everything we use on the original.
What is that? Do you know what that would mean?
The word an anonymous argument, and it can't dispatch. So there's 2 ways that this will come up. Okay, I'm guessing what they mean. We can read the A-bind has been around for a while. I can't remember who wrote it, but that's the other thing is. So it's actually fun. One of the things I did before this, I have all of CRAN. I pulled CRAN down for analysis. I can pull through and find out where all the code is, and you can also see who wrote what and whether they're reliable, how many packages they wrote, and when they wrote it. And so you can build up a sense of trust. We from our mailing list, we know who's who talks analysis and who doesn't and stuff like that. And anonymous. So S3 cannot dispatch on multiple arguments. It looks at one argument, gets its class, and then finds the corresponding methods for that generic function. Okay, but only one argument. For us, sometimes we want multiple dispatch. So I'd say I want to dispatch on a data frame and something else. Okay, so nothing we've seen before, it did multiple dispatch. Okay, but then there's an anonymous thing. So if the word anonymous is coming up in two different ways, potentially in two different ways. If somebody does this, if somebody defines a function that, so we've got a generic that looks like this, x and dot, dot, dot. Okay, so then if somebody calls, so this is called plot, let's say, if somebody calls plot of empty cars, which is a data frame, okay, and then they put in something like letters, okay. Okay, if letters, which is this is a character vector, okay, just the letters of the alphabet, that's goes into dot dot dot. S4, S3, nobody will look at what's in here. Okay, these are just dot dot dots. Okay, so that's why they may be talking about anonymous there. Where we frequently see anonymous things, we see things like this, where we will get something like lapply of x, and here's a function that takes an element and does something to it. This is called an anonymous function because it was never given a name, but it's still a function. It still has a class. And that the name of the object is not important. It's the class of the object. We could dispatch on this, on the class of the function here. That would not be a problem. This is where we typically use the word anonymous. So I'm not sure what they mean by anonymous, but this is in terms of method dispatch. This is not a named argument, so therefore nobody can actually say, take a look at the thing value, go get the object with the name that I didn't give you, and tell me what class it is. Well, I have no idea, you never gave me the name, so we can't. That's what I suspect they mean, but that's not S3. That's S3 and S4. Nobody can answer that question. Just go take a look at the parameter whose name I won't tell you, and dispatch on that. Okay. But S3 can't do the multiple dispatch. But anyway, what do we do with S4? Okay, it's more verbose, but it's much more structured, and it's just a good thing if you're familiar with Java and C++. You like this because it actually smacks you around the head. Okay, and tells you you're wrong. Okay, it also says when you start sticking things into these classes, it says that's the wrong thing to stick in there. That's not a valid object, so therefore you can't go past this, and you have to fix it. So you're catching errors much more rapidly. Okay. Okay, you can also query. I can actually say, I can go to an R package and say, what classes do you have? What methods do you have? Oh, okay, fair enough. And I can do this programmatically. I can show you little graphs of what classes are related to each other and so forth. It also actually defines structure or relationships between classes. Okay, and it also it also tests the validity, not just of did you put the right type into a field or the residuals and numeric vector. We can also actually say, and do they actually have a sum of 0? Because if they don't have a sum of 0, they ain't residuals. Okay, so for a linear model. Okay, so we can actually make assertions that are tested when an object is created about not only the structure but the content of the values, which is really very helpful. Okay. Okay, so that's kind of fine. And we also have this notion of an abstract class, which can be very helpful. What do you actually need? These are the functions for, okay, yes?
Questions when you said testing, that's in the previous testing for an object?
No, this is actually, I think I might say testing, but it is actually when you create an object, not when you're testing the software, but when somebody actually is using the software and they say, I want to create a linear model, and then they create it using one of these S4 objects, when we define an LM object, a linear model for S4, we could say, by the way, the number of residuals has to be equal to the number of observations, and also the sum of the residuals has to be 0. But this will be done at runtime when the user is actually deploying the code. The unit testing happens hopefully before we release the software, okay? Or when somebody's validating the software, but before using it. Okay? These are the methods we use. Okay? We didn't have really many functions for the S3 thing, just class, and then stick a class on the naming things. But this is a little bit more formal. We say set class, and we say for a linear model, it should have these elements, okay? And these elements should have these types, okay? And then we say, instead of creating a generic method by just having a generic function, by creating a function that calls use method, we have to say, create let's create a generic function with this name, and here's its definition, which is redundant because it says, here's the signature, here are the parameters, and the call standard generic. Okay, and then we go and define explicit methods. Okay, so we don't just find these casually at one time. Okay, we actually say these are methods. I meant these to be methods, and then we also have a little thing called set as, which is actually kind of handy. But this is just a wrapper for a set method. Okay, for a particular for the coerce function. Okay, so this is what we do. We say set class of something called Bob. I'll show you some. If you want, we can go through. There's some examples I pulled from some CRAN packages. Set class of Bob. This is the name of the class, and it has these fields. It has an x, which is an integer, and y, which is a numeric vector. I don't know why I'm making this up. Okay. For those of you who don't know, Bob is easy to spell because it goes backwards and forwards. Okay. So okay. Yeah. Okay. So and by the way, I return the value here if I want. Set class returns its function that you can use to construct one of these guys. I never use it, but you could just say b equals Bob and give it x and you give it y. Okay? And if you don't give it y, or if you don't give it x, it'll just use the default, which is just an empty vector. Now we may actually I may also add in a validity test. At the end of this, I say validity equals, and I give it a function, and that might actually test to see that those two have the same length, for example, or that all the values in x are positive, or all the values in x are greater than the square root of the mean of y, or whatever bizarre test makes sense. Okay, so I can do things like that. But we can use the constructor, or we can just use this generic, which works always. Create a new S4 object of what class, that class, and then here are the slots I'm giving to you. Okay, and I say when this happens, when you call either of these, it says wrong. You gave me a logical vector, and I expected a numeric vector that can't go in there, or it'll try to coerce me. Okay, or you gave me a data frame, and I expected a matrix, wrong, so it'll just fail to actually create the object. And then when it creates the object, it runs the validity test and says wrong. The contents are wrong. The types are right. The content is wrong. And then when you get it right, it goes, okay, thank you very much. And now we're ready to. Now we have an S4 object, which is just like any other R object, except for it's slightly different, but you don't really care. Okay, happy? So this is how you define these. It's a little bit. It gets a bit richer later on because we can explicitly put the inheritance in. Okay, as to what the base classes are, and the super and the derived class. And we'll see that in a second. Okay. Okay, if you want, you can take a look at these two. We can come back if you want. These are two just packages I pulled not at random because I went through and I filtered all the packages. Which ones have S4 code? Okay, and there's however many there are, and I looked at these two because one is Robert Hyman's package, which is okay, and the other one is Hadley's been involved in, and it actually kind of has some interesting oddities in there too. Here's a simple example. I kind of threw these together in a slightly odd order. This is a concept of so this might be a good example of using a class. Again, there's no good example that I can explain in 2 seconds. Otherwise, I have to go through a whole use case, and 3 hours later, we're going wasn't there something like classes at the end? Okay. So that's the thing. So we have numbers, but it's actually really nice to put labels on. Okay, to say these are actually Celsius or Fahrenheit. In which case, then we can actually start doing really fun stuff. Okay, if I have one set of data in Celsius and the other in Fahrenheit, okay, or in meters and feet, like they did in the river that collapsed. Okay, when we want to actually make sure we get this right, we can define methods that say if you subtract the Celsius from Fahrenheit, we'll convert the Fahrenheit to Celsius and actually do the right thing, as opposed to doing the arithmetic in entirely wrong units and getting nonsense back. So this could actually make your code a lot richer and more robust. So what we can actually do is we can actually define a thing called, we can define classes for all of these. How many of you know about this type of measurement, this type of what the physicists do? I just don't know. Okay, let's pull up these ones. Okay, and there's a whole bunch of people who are measuring things in wacky scale. Okay, so the other one thing you got to be careful about here is when you're defining a class. So latitude and longitude are also measured in degrees. And they ain't the same degrees. Okay, so if anything, we do want to say these are. So I say these are temperature degrees, and these are different degrees. But if you just get the name wrong, because you're thinking with tunnel vision, anyone who mentions the word degree is talking about temperature. And then other people are going like, no, there's longitude and longitude. And other people are going, no, there's masters and PhDs and bachelor's degrees. Okay, so we actually want to keep these separate and put a name down. But we can keep them all separate. That's fine. But you also want to think about how you represent them. How would you represent Celsius and Fahrenheit? Or any of these degrees? I mean, I'm going to represent them. They're going to be numbers in R. So how do we do this? So if you do this in S3, just put a label Celsius. And I would probably put down, if I was doing this in S3, I would probably put down, it's Celsius and it's a temperature degree. It's Fahrenheit and it's a temperature degree. So I actually get that it's a temperature degree. And then I could write everything in terms of temperature degrees. I could write all my methods in terms of temperature degrees. And if I had to specialize them, I could make them more specific to that. So that was the S3 method we were doing. We're going to do the same thing. Okay, we can do the same thing. Okay, do I actually, hang on a second, where do I put it in? So we could do something like this. Set class temperature degree. And this is the bit that I actually do, okay? I don't want to just start temperature degree. And then I could say set class temperature degree. And then Celsius contains temperature degree. The word contains is getting the inheritance. So a Celsius object is a temperature degree object as well. A Fahrenheit object is not a Celsius degree, but it is a temperature degree. Okay, life is great. But the very first one, I'm going to basically say temperature degree is a numeric vector. Okay, and that means I can use it in place wherever we want. When we call range or summary or any of these things on a numeric vector plot, we want to inherit all of those things. So this is a temperature degree is the numeric vector and has all the same properties, but it's got a few more. It's a little bit more specific, and that's what we're getting at in inheritance. Okay, and then these guys are even more specific, and then we can go off. Okay, so implicitly in this, we have these is relationships. But I can say I create a Celsius object. Is it a temperature degree? Yes. Is it a Fahrenheit? No, it's not. And we don't necessarily need to use the is function, but it's getting used all over the place because of this direct definition of the class hierarchy. Okay. I want to go back and look at something soon, but okay. So we've defined classes and we talked about inheritance here. If you've understood the inheritance, it's the same idea, it's the same concept. How do we define it? Through set class, that's all. Okay, but now for methods, we have S3 methods. All we did was plot.name, and that was it. We didn't have to do anything. Now we're going to say set method for the plot generic function. Okay, and if it's already an S3 generic, it will be automatically made into an S4 generic as well. Okay, just magic will happen. You don't have to do anything. If we're saying set method on foo and there's no foo, well, we need to define a generic. Okay, and just say, okay, you just use standard generic. Okay, so we say set generic of foo, and we create a little function. I can write that code down. But this guy here, what am I going to do for temperature degree? I don't know why. I'm making this example up. Okay, okay. What I'm going to do, so if you actually do this, because we're inheriting from a numeric vector, if I just plot it, it will just plot the values along the, okay, it will just plot them up, 1 through n along the horizontal axis and the values on y in corresponding. I don't want that. I actually want to look at the temperature distribution. I don't know why. I'm just making this up. But because we have this, so what do? We just say, I'm going to define a method for all of these, Celsius, Kelvin, Fahrenheit. So I will inherit that method for all of them. Okay, so I'm going to define it on temperature degree, and that means I don't have to define one for each of the subclasses. Yeah? But what if we want to define methods for a subclass? I can do that. I just say set method on Celsius, and I just, instead of drawing a density plot, I'm going to draw a bar plot of some other unrelated data, or I'm going to do anything I feel like. I can just completely override this. Okay? So I can override the behavior, or I can just use it, I can just inherit it and get the density. Or I can do what we did with the next method. I just do something and add something else. So again, struggling to come up with an example I can describe in 10 seconds. Okay, what do I want to do? I want to draw the density plot that I want to actually put down freezing and boiling points, which is going to be different for
all these points. So I'm going to custom. I could write another generic function that said give me the boiling and freezing points, and then I would write 3 methods, one for each of the 3 different classes, Kelvin, Fahrenheit, and Celsius. And then I could write a generic function for temperature degree that uses that call. I could do that, but I'm going to do this for Celsius. I could actually just write methods, and this is the same thing as next method. Okay, it just says call the next method, which will produce the plot of the density, and then we're going to decorate the plot afterwards when we come back. Okay, that's all there is to it. So again, it's the same concept of inheritance, but a lot more structure now at this point. Okay? Okay?
From what I see here, I can imagine the code could be so unorganized. It's because when you have like in like for example Java, you define a class, and then under that class you define your methods. But here you can just write this set method anywhere because you're just referring to the Celsius. So it doesn't have to be in one block, you know, it just can be anywhere.
Not only, so you're saying that it could be another file?
Yeah, I mean, yeah, somehow that
it could be on another machine.
Yeah, exactly.
That's the beauty of this, is that it's no longer the author of the code who actually controls how involved. It is actually, I come along and actually I define this method. It's a bizarre way, I mean, it's, for those people used to sort of locking code down, and so saying there's a single author and it's all organized inside one single definition. This is very different, but it is incredibly rich and powerful. And amazingly, it doesn't cause chaos. So it's the same thing about open source. Everyone said it's just chaos. It's the cathedral in the bazaar. They used to call it, you know, and yet it works, and it works really well by actually allowing all of these little seeds to grow. Good things happen. And so as Larry said, you know, this is the same with S3 and S4. This is the global view of the world as opposed to the hierarchical method being defined inside a class. But even in Java, C++, Python, subclasses can be defined. Whoa, totally different packages and modules. So yeah, it's kind of bizarre. So there is a little thing I didn't tell you about the next method in the S3 world. You can do any computation you want before you call next method in your method for that subclass. You can do anything you want, and then you call next method, and you never come back. Anything you do afterwards is ignored, which is annoying. So I can't actually do this with the next method. It's just a stupid implementation issue. But this one is much more flexible. I can do computations beforehand, and I can do computations afterwards. Okay, so I'm inheriting the method, invoking it, and then moving on and doing good stuff. Okay, we'll talk about the thing. Somebody said, what?
I just said hot.
I know, I heard that, but about what? About this? Oh, sorry.
For calling next method, so like you can just like start referring to stuff like before you started setting methods.
So I got arguments in here, and I can do all sorts of computations on these arguments, get them, prepare them all, and fix them up, change missing values, drop missing values, and all sorts of stuff, and then say now call next method with all the data that I have here, and then come back and now let me tidy up so I can pre-process and post-process the actual inheritance. Yeah, it's a handy thing. But again, the key thing about this is that, you know, there's all these mechanical details to report. Okay, but it's like what are we getting? We're getting code reuse. We're getting code inheritance, so we don't have to retest code. We get the beauty of being able to do this in different packages, different machines, in the privacy of our own home without actually having to have proprietary software and all that sort of stuff. We've got in S4, we've got a lot of testing going on, and a lot of automatic checking, and a lot of structure, and that can be very useful. So it's more the mindset that is actually getting it here. And if you think this is only for software engineers, S3 is not. Okay, S3 can do it, and S4 is really not big actually on it. So it can actually help you do your own to write your own code. Okay, it's very much the R spirit of incrementally going from writing an individual line of code to writing functions that are a little bit more structured to a tiny bit more structure. There's funky stuff here about virtual things that we can have. You can actually have classes. That temperature degree, no one should ever create a vector of class temperature degree. It doesn't make any sense. You're either Kelvin
Fahrenheit or Celsius or whatever it is, but you are not temperature degree. It means you haven't told us what the actual units are, so you shouldn't be able to do that. You can create these things called abstract classes, which work very well for saying we can inherit from this. We can define methods on them that will be inherited, but nobody can create an object of that class because it doesn't make sense, okay? And there is this other thing that I use a lot, which is this. You can also do this thing, which is, maybe I overuse it, but it makes my life so simple. Think about this. I just, in this really PDF where we were talking about last week, if you were here, not making a difference. I have all these functions that say, just like the tesseract says, if you give me a character vector, I will immediately turn it into a document. Like I will parse that document. You give me the name of an image file, I will read the image file. Okay, so because I need to work on the actual contents, not the file name. So I have this litter around places. If the argument name doc, okay, which should be is. Okay, sorry. If is doc, if it's character, just do this. And now I keep going. Now I could write a method for every single function. Right? A lot of these functions, by the way. So now we get into multiple copies essentially that just do exactly the same thing. So I like to use this idiom. Okay. So it's even worse when I do this, which is if it's a character, then it's the name of the file. So please read the file name. But if it's a page of this document, then go back to the document. If it's a node inside a page, go back to the document. Oh, this is the if statement problem we have at the beginning. So like, okay, you don't need to worry about extensibility here as much, but it's just becoming, it gets really interesting stupid. This is what I like to do. Doc equals as doc PDF to XML. Doc, okay? This is what I want at the end. This is what this function returns. If doc is one of these things, it's a no operation. Okay, just don't do it. If it's a character, I write a method for set as to do this because I know what the target is. And if it's a page in a document, I make it into the document. And if it's a node, I turn it. So now again, I write these tiny little functions that say, I know how to get from here to here. I know how to get from here to there. I know how to get from here to another place. And then I just start using through the, and my code is now one line rather than a repetition of a whole lot of if statements, which I think I find particularly useful. Okay. And then we sort of do all these nice things. We do all these nice things. Let me just show you this one thing. This is code from the R tesseract package. There's other examples too. I just quick for me to find. Remember I was talking about this square bracket operation? X and missing guys here. So what we actually have is here, we have read in an image, and I pull it back from tesseract as a big array. It's a two-dimensional matrix essentially, but I haven't pulled it back yet. They're big. And if I want to just pull out one column, I do not want to copy the entire thing back and then pull out that one column, that one pixel. I want to be able to do this much more intelligently in terms of use of memory. So what will I do? I'll basically say, if I have a pick object, so the class called pick, if you use the square bracket function, and you give an x is the pick is the image, and you give me nothing, no rows, no columns, just give you the whole pixel, give you the whole the image back. But if you give me back if you tell me the rows, but you want all the columns, we'll handle that for you too, and we'll do it quite differently because again, I will be very clever about how I go in and pull out the data. Okay, and likewise, if you give them the other direction here, where you don't tell me the rows, so you want all the rows, but you just tell me what the columns are that you want, that's fine. Okay, and then likewise, we go down here. We should go down. We should be able to deal with logical values because that tells me which rows you want. And you tell me which rows as true or false. So what do? I don't care about the trues and falses. I just turn those into integer values, which identify the rows, and then I'll just call the other method back up here again. Okay, so we can do this, and this is an example of this is an example where we're dispatching on we're dispatching on the class of three separate arguments. Okay, the first argument, the second, and the third, and we need all three of them to define the method. And this makes, again, if you're used to using Java or C++, this happens automatically. You can write these methods that have different signatures, okay? And that's, so it's nothing spectacular, but it's extremely powerful because now, if you think about this, I don't know about you, I was just saying, she showed me a paragraph, and I said, that's too much, I can't read paragraphs. And the bullet points, I think it's a very short sentence, and the attention span of a single sentence, a single line, it's not even a sentence. So when I look at this, I can reason about this, but if I put all of this into one big function, okay, and there's more of this, but I mean, this goes on down for, this is just a snippet of it. It's 53 lines of code or so. If you put that all in one function, it becomes a nightmare to actually manage, okay? And that's the, so this is the S4 mechanism for actually being able to do multiple dispatch that actually gives you even more specificity and be able to carve out these different, different pieces. So this, by the way, this is actually, this is, I saw it, never mind. Okay, there are these funky things about if you're putting them in packages, this can actually cause you some grief. Again, it's really good to put things in packages so that you can just share it quickly. People can install it on GitHub with ease and stuff like that, including you on a different machine. You can get this. If you want to basically export classes, you have to import the S4 mechanism, which is in the methods package. So you always import the methods package. Then if you want to give people access to your classes, you export classes with their names, you export the generic function that you create, and then you export all of the methods from 1, from 2, from 3, okay, for the generic functions, and then life should just work. If not, come talk to me if there's any problem. It can be slightly weird. And there is this thing, the debugging works on all of these. It just follows, if you debug a generic function, it will follow the methods so you can actually see what's going on. You can also say, you know, the one real problem about S3 and S4 methods is, I know it's going to do something. I can walk through and debug it, but like, why? Why did it dispatch to that method? Because especially when you're in the work when we're dispatching on 3 or 4 arguments, you feel like, we got different class hierarchies. A inherits from B, inherits from C. And like, oh, which one's it going to get? Which one's it going to get? You can ask it and say, which one? Why? And then you can say, I made a mistake in when I defined these methods. Or I made a mistake in anticipating what would be this. I see why it would work or whatever. And you can fix this. This, by the way, is this one last thing. Okay? This thing I say. I use it all the time. I'm using myself, and you can make fun of me. Okay? Where it's basically, if you do this, if you have a function, there's nothing to do with classes. It's an idiom. We do this. So we write a function called do. Takes a directory and not even maybe again. We list all the files in the directory. Then we go through and ask all of them for their file information. And then we just give back just the directories. Okay, and then I'm going to do something on the directories, and we go through and collect their namespace files or something like this. So what's a better way to write this? The most obvious thing to do is put dot, dot, dot in here, and then pass dot, dot, dot down in here, because this won't work if you don't do that. Okay, and this gives full control to the caller to actually pass down additional arguments. It's a little bit, if they need to pass arguments down to these 2 functions, then you've got to actually start giving them names. But that's okay. This is a big improvement. Okay, but then the problem with this is I did this on Crown. And, there's 12,000 packages there and a bunch of other directories. This takes a few seconds to actually go and do this. So I want to do it once. And then I'm going to do something after this. I haven't bothered putting something in, but I want to do something afterwards. So I want to basically be able to specify a subset of the directories. Or I want to be able to pass in the information and the list of files so that I don't have to actually recalculate these every single time. Why? Because I'm debugging this. The next step, I'm debugging. And I don't have half an hour to wait between development cycles, okay? So I kind of want to be able to do this. So this is what I can do. Okay, just take a look. Okay, here we are. I just literally do this. Dot, dot, dot is not getting in my way, okay? But I just take this parentheses and the curly brace, and I move it down to the bottom down here, okay? I get exactly the same function. Okay, just moved it down, okay? You can specify the files as a parameter, but if you don't, I'll compute
I'll compute it for you. Haven't changed a line of code here, except for just the order of the line. If you want, you can give me an info parameter, but if you don't, I'll compute it from the files, okay? Which is defined here, but if you don't give me the files, I'll compute it from the directory. And then if you compute it, and if you want to bypass the info and just give me the directories because you know that this is directories, then great. I'm just going to operate on the directories, and we can save a whole lot of computation, which is kind of nice for other users, but it's really nice for you if you're developing. I can just take 3 directories, and let's see if the rest of the code runs. So again, what you can actually do at this point is actually get every line of code out of the body of a function, stick it into the signature, and just end up with a return of the result, which just seems a little bit too much. Okay, I'm not suggesting you go that far, but this is actually kind of a nice idiom because it makes the code much more flexible. Okay, you can now the caller really can control every little aspect of this. Okay, and that means you when you're writing anything. You can take it too far. You really can. I know that. Okay, but it's kind of a nice little trick. But it does actually allow you to say, because I often see people writing functions, they write a function that just do some preparation on their data, then do something, and they make a plot, and they hard code the colors. Nothing should be hard coded. No literal value should ever be in function. It should always be operationally changeable. In which case, now, well, hang on a second. You can start creeping everything back up. And because R is this lazily evaluated language, and because it has default values in here that can actually refer, it's much richer than C and Java, which also have default values, but nothing like this. These things can all refer to other arguments, and the whole thing can just wait to get evaluated in exactly the same way. So literally, the code that you write inside the body can get lifted up in cases. And in some cases, there's some cases where it just gets ridiculous. You have to have huge if statements, massive blocks of code. That's stupid. But for things which are just going to get done, you can just actually say, no, I can bypass this computation and this computation by just giving a vector of like 3 ideas, testing my code. Behaves perfectly. And somebody else may want to do this and be fed up having to wait for the list.files and info to work first when they actually know better than you what you want to actually do. So they can reuse this code in a much richer way you hadn't necessarily planned. Any questions?
Just triggers a question for me. So if you include that dot at the top level, let's say that you didn't define info and DIRs here as arguments, they were something in the body. But if you have that,
so we just want this.
Yeah, so right, you have that. Does that allow somebody to pass in values that aren't going to get passed down to other functions, but for example, pass in their own version of that file.info function, so that it changes the behavior inside that function?
So sorry, that's just so we have this, and we'll just take
move those in, the body.
Okay, and we have ... here. Okay.
Yeah.
Okay, and now so paste
those in.
Okay.
Into the body.
Oh, sorry.
So let's say I called do with, and then I one of the arguments I include is file.info equals function. Define my own function to override file.info that's called there on line 3.
Oh, so now you're saying, okay, so we're saying you're putting in dot, let's say, and now you're saying info equals
a file.info, since that's an actual function that's being called in there.
Oh, so you're going to say file.info
equals function, and I define my own function. I'm wondering if I can override things inside.
Not a clue.
No. Okay, so it's only for passing in.
No, and that's why I'm saying once they're in the body, info is now you're saying no matter what happens, run this line, okay? And so you will execute this and then assign the results to info. And you as the caller cannot influence that whatsoever. That will happen. Even if you pass in info equals 1, okay? It says, I don't care, I'm just ignoring info. Okay.
Right, but I guess what I'm getting at is, can I pass in file.info instead of the info?
No.
Okay, pass in a function that will be called by that line 3. So when info calls,
okay.
look up something that I passed in
yes.
up
Yes, you can.
Yeah,
Yes, sorry. Yes, in that case, sorry. Now, sorry. That's.
I know it's confusing.
No. So what you would now do is you would do. Sorry, now I'm with you.
Equals function.
Sorry, you did say that. And I was going. I don't think I've ever heard that question. I think you deserve a reward for that. Most novel question I've heard. Yes, that we should check that we can do it absolutely, because now, if you know, I've done this our fundamentals class. I draw this diagram of where it searches all the time, so it creates a new call frame for this guy. Okay, and then this guy's again. So the answer is no, it won't work. Okay. The answer is no, it will not work. You see conjecture, okay? No, because, and the reason is because you can't get at the ... without actually saying a list of ...
Okay.
So the ... remains as a list, okay? And it has an element named file.info. But if I do something like, so that won't work, that will actually find the correct one. But if we do something like this, which is args, and this is a bad thing to do, okay? We do this, and now we say args$file.info. It'll be absolutely fine, okay? This is the scoping argument here, but no, the ... don't just get slid in as, they're very special objects. So we have this call frame, and we end up with an object called dir, a variable called dir, another one called files in this case, and then we have another one called ... And when we pick up ... and pass it in here, then it's when we unravel them and treat them as individual arguments. But when we look around for variables in this thing, we see only ... as a name, and we don't look inside it for its name elements. Yes. And that's one of the, actually, and that's actually one of the reasons why I teach that thing. That's an example, so that you can reason about the logic of this, because otherwise it makes perfect sense that it could just take a wheelbarrow and shove them all into that call frame with their own names, things, in which case you could say file.info. And then the one thing we didn't talk about was reference classes, which actually gets you into some funky stuff like that, where we would find a file info that was actually part of a reference object. Again, I'm kind of, and if you want to ask me about reference classes, that's fine. Use them to your heart's content. I don't like them because they make it really hard to reason it because of the side effects. But they're very similar to what we do. All the inheritance, all the methods. They don't give you the S4, unfortunately. Any other questions? So this in comparison with C++, this is a lot. Good. Okay. See you guys. We meeting later? Oh, we meeting later.
Can you, okay. Sorry, can you push the update your last version of the slides?
I can. You know that there's that I've changed them? Yeah, I think I did. I think there's still some oddities to them. I thinking.
She's reading a mystery.